Sir, good morning, Moiz sir.
Sir, co-system.
Moiz sir, good morning.
Yeah, good morning.
How are you, sir?
Yeah, fine, fine, thank you.
Right.
Very good morning, sir.
Yeah, good morning, sir.
Yes,
Sir.
Respected, today's second session, resource person, Dr. Salman Abdul Moiz, who is professor in Central University, Hyderabad. It's really my privilege to introduce about sir in a very, in a very simple way. Sir presently working in Central University, Hyderabad. Sir's areas of interest are software engineering, mobile databases, and e-learning. Before this, Sir was a professor in CSE department, Geetam University, Hyderabad campus. At the same time, professor IT department, MVS Engineering College. Then he worked as research scientist, Center for Development of Advanced Computing, Bangalore. Then secretary, CSI chapter, Hyderabad. Member, Board of Studies, Loyola Academy, Hyderabad. Advisory Council member, Engineering Staff College of India, which is very prestigious institute. ESCI Hyderabad. Then member Department Advisory Boards of CSC and IT, Mufkanja College of Engineering and Technology. And fellow IETE, member IETE, ACM, IE, and EWB. Sir is really having very vast experience in this learning. In fact, sir is a well-wisher. In fact, whenever we call, in fact, without any hesitation, sir is really supporting us. Is having very good number of papers in both national and international journals with a high impact factor, involving very good research. Very good number of research scholars are working under his able guidance. It's really proud, sir, about your presence with us today.
Thank you.
For your kind acceptance and sparing your valuable time. Warm welcome to you, sir. Thank you.
Thank you.
Over to you, sir.
Please allow me to share my screen.
Yes, sir. Already we made you co-host, sir.
Okay. So shall I stop the screen?
Yes, sir. Yes, sir. Yes, sir.
Okay. Yeah. So I think my screen is also visible.
Yes, sir. Yes, sir.
Yeah. Okay. Good morning to one and all. So I have seen that, probably so many speakers were there in this session where you might have really got about most of the concepts of machine learning and its application. Okay. So let us discuss about visualization here, which is very much important these days, specifically with the enormous amount of data which is flowing into the systems. So visualization plays an important role. So initially we'll just talk about, different types of visualization, why visualization is needed. Okay, where it is needed in the entire data science or machine learning process. Okay, then probably since it talks about, we'll also talk about a little bit of research directions where we are working into the visualization. And probably you may start enjoying some of those things. Okay, of course, people mostly use the basic visualization where the only very few factors to be considered. So we'll also see several other aspects of visualization as well. So I start with my talk, with a famous saying that no matter what data you analyze, visualization is necessary. I think you might have studied about a lot of analysis, learning algorithms, and so forth. But of course, even whatever you have it, but unless and until it is visualized properly, it is very difficult to identify the patterns into the data. So you might be talking about, you want to, of course, know the patterns into the data, of course, trends from the data to be found out. Okay, becomes very difficult if you do not visualize them. So we will also see that when to visualize, the things, and let us go about it. We'll talk about, of course, I said what called data science. It is machine learning or data science. We'll talk about that data visualization. We'll also talk about the visualization process. I discussed that, specified that word called process because we need to really know where data visualization stands into the entire process life cycle. Okay. Then we'll talk about need for data visualization. Okay. We'll talk about some of the tools of data visualization. Then directly we'll move on to some of the research directions where we are working at, and of course, throw some lights to you. So that will be the layout of the today session. So let's move ahead. So I'm not talking about, most of the data science, it's maybe machine learning as well. Only the thing is the difference there is nothing but machine learning in addition requires the domain experts to make them data scientists. So in most of the cases, you have to, of course, interpret the data. You have to get the insights into the data. You have to get the trends from the data. You have to get observations from the data so that you can interpret it better. Okay. So what is data visualization? We start with this. So it is the process of understanding the significance of the data by placing it in the visual context. That means to say, we don't want to see those tables. We don't want to see the core data. Instead of that, we want to visualize the same data into the graphical format. So that what happens is actually in the text-based data, you cannot notice all types of patterns and trends. Okay, though there may be very important patterns and trends to be noted, but in a text-based data or in that particular tabular format, a huge amount of table and matrix, it is very difficult to identify the patterns or trends. But instead, if you visualize it, it becomes very easy to notice the patterns and trends into the data. So what that does mean, it basically involves presentation of the data into the pictorial format in the simplest way. That is what a data visualization is. So here you got to know what is data visualization, even little bit of the background of it, why it is needed. So let's move ahead. So here I would like to spend some time onto this process because you need to really know where visualization comes into picture. Okay, forget about a machine learning process or a data science process here. So you basically collect raw data. So raw data is collected, which could be collected through various sources. It could be data coming from various files. It could be data which is coming from various sensors, of course, and various other sources as well. Of course, then data has to be processed. For that reason, first thing is you need to clean the data set. You might have studied about data reprocessing and all those sort of techniques coming into picture. Here, first you have collected the data. Okay, and the data usually has noise into that. You might have already discussed in so many forums, and you have techniques like data pre-processing techniques, which is used to clean this data set, or we also call data wrangling process. So once it is done, you do the basic analysis onto the data, which is said to be exploratory data analysis, and based on that, you have your models, your algorithms. You see that system learns with this particular data, and your learning comes into picture. Learning algorithms comes into picture. A lot of such models and algorithms are built there. Now, before we can convert this particular entire thing into a data product, you have to visualize it. So to make the things very simple, you might be talking about data, a lot of data. So based on this data, you have applied some algorithm, some machine learning algorithm, of course, to identify the trends and patterns. But what you need to do is, before taking a final decision, you need to visualize it. You need to use some visual tools to visualize the same amount of data. So that what happens here is, and you do not stop there. You might have talked about feature engineering in your previous talk. So you have so many features which are used in making this decision or to identify this particular trend coming up from the data. So what we do, we play with this particular data, which is nothing but features. You modify the features, you vary the features, Then you again visualize and see how the changes are being captured in that. So that is where it comes into picture. So what happens here is once you develop your model, okay, and implement your algorithm, before you take a final decision, you have to visualize the data. So communicate, visualize, report comes into picture there before it is transformed into data product. But of course, based on this particular visualization, the decisions are made actually, because the entire trend of the entire data is very easily visible into the visual form. But of course, there are a lot of ifs and buts which we'll discuss in the coming slides. So I think you got to know where visualization comes into picture. You could visualize it. And I could also add to you that you may not always visualize after making your algorithm. Before making an algorithm also, there are certain visualization tools that will be helpful. Like I do my exploratory data analysis. Immediately after that, I would like to visualize it. Okay, probably might have used some of the charts. We'll see. One of the basic charts that is most commonly used when we do EDA is their box plot. We'll talk about it so that we really get to know the summary of the data. So based upon that, we can go and the next step can be taken. So it is not fixed that you have to visualize only after the model is done or algorithm is done. Even after your data analysis, exploratory data analysis is done, you could visualize your data. Yeah. So let us start with the taxonomy of data visualization. This is very important to understand if somebody wants to make a career in data visualization. So there are three branches of data visualization. One is said to be a scientific visualization, information visualization, and visual analytics. In fact, one need to start with information visualization, which is mostly needed in case of our machine learning and applications. But if you go ahead with the image processing and all, we require a scientific visualization. But of course, we'll come to know that both alone are not sufficient. As such, we also require a visual analytics. Though sequential wise is like this, but you do first information visualization. When you master it, you can go to scientific visualization. Then you go to the visual analytics. Okay. So generalized data visualization involves, actually data visualization is nothing but a multidisciplinary field. That is very interesting to know that. So it involves information technology, natural sciences. It requires a lot of statistical analysis. But that's where we say the prerequisites to all this is statistics is needed for you. You require a lot of interaction, you require a lot of geographical information. So let me pause here and of course, explain you of course with one of the example which we were doing as a project. Okay, I'll not give you most of the details. So we had a lot of data collected from our organization which was working with us. So they gave us data of some objects. I don't want to mention those objects right now, but they specified the positions of those objects. Okay, in terms of GPS. We got that. Okay. We were actually asked to find out some accuracy about one object interacting with other object. Okay. I'm just keeping these black boxes because of the confidentiality. So one object interacting with other object. Okay, what is the probability? Okay, how much chance is there so that this particular object interacts with that particular object? No, we did, we have developed some algorithm. We did that simulation. We showed that, of course, there is a 0.9 or 90% in the chances that this object interacts with this in this scenario. In another scenario, it is about 98% and so forth. It's very easy to see those particular words. But in fact, it is very difficult to visualize how actually it's happening. So our organization was said, okay, but we are not able to understand that. We need to see it, how it happens. So then what we need to do is we converted those particular, of course, the coordinates into those objects, what they are referring to. And we have to use a geographical information system tool to place those objects into that and run our algorithm to visualize that. Okay, so that's what it is needed. It is not only just getting some accuracy, okay, measure and just keeping it quiet. It may work for some data, but it comes to the real life, it has to be visualized. Because you can understand accuracy, I can understand accuracy. There are other metrics as well. You might have also gone through in your previous sessions, right? So when you have done these particular, measures, what happens is the end user, it is not beneficial for the end user. So it requires visualization. So that's the reason we should also know what of thing could be visualized to which target people. Okay, that is what is needed. So please try to understand that data visualization actually involves it is a multidisciplinary field, which has IT, natural sciences, statistical analysis, a lot of graphics is there, and so many objects interact. Geographical information I already talked about, where we require the coordinates where these particular elements or have to be placed in the space. Yeah. So we'll just see what is scientific visualization. Okay, it's an interdisciplinary research and application field in science. Okay, focusing on the visualization of three-dimensional phenomena. It is basically, of course, it is used to visualize a three-dimensional object. Okay, it is used in architecture because when you talk about an architecture, you know very well the architecture cannot be viewed in cannot be seen only with a single view. The architecture has to be seen with various views. And medicine, so let us suppose if you talk about a particular CT scan image. So what happens here is you will have various views of that particular thing. You'll have so many boxes there. One specifying one view, another specifying another view, right? So why it is used for, the second part is very much important. Its purpose is to graphically illustrate scientific data, enabling scientists to understand, explain, and collect patterns from the data. Now here I give an example, which I was also discussing yesterday. Whenever probably I took my mother to a particular hospital, they said, do that some CT scan. So then the doctor was explaining me by showing this image onto a very big 3D screen. And he says, so muscle, there is a gap in this muscle. This gap should be like this. Okay, a little bit less, it is a bit higher. So what is he doing? He is able to explain me the problem with that particular representation. But what is stored for us there? So probably what happens is, as a machine learning, machine learning person or a data scientist, what I could do is, okay, maybe a patient of this nature has got this gap. Can I collect some of those particular causes? Okay. So if my law permits, I may take some more details from the patient. I'll ask whether the patient is diabetic, whether suffering from some other thing. I'll collect the age, and I may collect so many such data. Okay. So I can even visualize the new person coming into picture with those particular features. May not be always correct, but of course, this is the other way where you can even visualize the patterns from the data through your learning algorithms. But basically, do remember that this is used for visualizing a three-dimensional phenomenon, which of course, those who are new to the visualization will not start with this. But you need to understand that its purpose is to, of course, what you have to understand, explain, and collect patterns from the data. You can also collect patterns from the data which is happening. So you were able to see so many things here. Okay, some images, some CT scan images, some X-rays. All this comes into this particular thing because they represent a 3D phenomenon. Yeah. Now coming to this particular information visualization, this is what is we have to start with it. If we haven't done any visualization till now, this is the first step to start, and most of you do it. Okay, it's the study of interactive and visual representation of abstract data to enhance human cognition. That's what it is. The data is usually abstract, but to understand the data properly, we need to go for information visualization. Data could be in digital format or a non-digital format. Okay, so you use a lot of graphs. You might have seen it. You use histograms. You use trend graphs. You use flowcharts, tree diagrams, and so forth. Now here you need to understand it. Actually, we do a lot of information visualization. But actually, probably we will not achieve our aim. That, probably you might have studied in courses like software engineering and all. You draw so many diagrams, object-oriented analysis and design like thing, right? You draw a use case diagram. Okay. You might have drawn a use case diagram. You might have drawn a particular sequence diagram. Or at least people might have drawn a flow chart. Okay. People might have drawn some class diagrams. All this comes under information visualization. Now, why do we draw these diagrams? We want to, that is, visually represent abstract data so that people can understand the system better. That is what the first step of visualization. Likewise, I have a data. I need to get the first-hand information of this. What are the basic characteristics of the data? Can I visualize it? So there we have to use this sort of graphs. So we have been doing visualization, but probably very well, like most of our students, what they do, they just draw a diagram. But the goal is not to just draw a diagram. The goal is to give the visual representation of abstract data so that it enhances my understanding of that particular system or data. So you might have seen a lot of graphs, what you studied, line graph, bar graph, all those sort of graphs. comes in the form of a information visualization. Not only that, you might have talk about tree diagrams, flow charts, all those particular analysis and design diagrams, they are for information visualization. Okay, so we can start with this. Slowly, you can go to the scientific visualization to visualize a three-dimensional phenomenon as well. Yeah. Then we have something called visual analytics. This is the next step. Okay. It is actually, it combines with the best features of both information visualization as well as scientific visualization. Okay. So here what it does, it of course identifies the 3D as well as it gives a charts and diagrams. It collects both of the things together here. So visual analytics is a new field that has evolved with the development of scientific visualization and information visualization, with an emphasis on analytical reasoning. So the emphasis is on analytical reasoning through interactive visual interface. So there is an interactive visual interface, and visual analytics becomes very important today because probably you might have seen when you have read about something called characteristics of the big data like concept, where you had something called velocity. Okay, you might have heard about velocity. So here velocity where data is coming, okay, at every second. Okay. I need to visualize at that particular moment of time. So then I need to go for a visual analytics because we require to analyze the data through interactive visual interfaces. Now, of course, probably if you see in this context of a virtual workshops like this, sometimes it becomes very difficult for us to know whether students are or participants are really listening to us. Yeah. So that becomes a very challenging task. So can I do some visual analytics on this? That's the reason I've seen some of the FDPs, they said, sir, please give some questions so that we can ask them in middle, so that we would like to see whether people are present there or not. Instead of that, what I do is probably I can say that everybody please keep your camera on, and I could take that particular data, and at every second I could see these particular graphs represented in various form based upon the data which is coming. Okay.
Division అంటే CSC లో వీళ్ళు ఇట్లా అంటే అట్లా డివైడ్ లేకపోతే
సబ్జెక్ట్ అలాట్మెంట్ చేసుకోవాలి కదా 2-1 2-2 కూడా ఇప్పుడే అలాట్ చేసుకున్నాం అన్నమాట. ఎందుకంటే ఇదేంత సార్ 4 నెలలు.
Okay. So here the visual analytics is very much important field when you have a streaming of data, okay, where data coming up in every second and you want to analyze it. Like, probably we gave an assignment to our student, very interesting assignment, where what was there is nothing but, in fact, that was implemented. You will be very much surprised to that. We have placed a camera in the classroom, okay, because we also work on learning technologies as it was introduced. So our probably one survey was, you can listen to a particular teacher only for 25 minutes. After that, you are lost. Either you have to change your pedagogy, okay, or you have to change the way of your teaching, or you have to introduce some exercise in middle so that they are back to the class. So what we did is we have placed a particular camera. The camera will take the the faces of the student, and based on that, it gives some analytics that probably 20% have closed their eyes for more than 2 seconds or no more 5 seconds and so forth, and it displays it. Then I can understand. Okay. And of course, maybe if 25% of the people have yawned in the last 5 minutes and so forth. So probably those sort of visual analytics will help us in that. So a lot of things can be done. Probably you are getting to know that but it's better to start with the first thing called information visualization, going towards scientific visualization, then coming to this visual analytics. We will see whether there are some tools available, how to do it, and so forth. Of course, I am sure that everybody sitting here knows information visualization, yet we'll have some recap of those particular stories, okay, based on our time. Yeah. So need for data visualization, the amount of information that humans gain through vision is far beyond that of organs. You all know very well. People use a lot of statements on that. Picture speaks. Earlier we used to have a word called picture speaks 1,000 words. But you know very well, today it is obsolete. The picture speaks a petabytes of data. That is what today, right? So of course, very well. If you see my image, probably, I think once you might have seen me on the screen. And many people might have, oh, this is Salman. We understood it. Okay, we know who is this. Like, probably, I do not know that, Rameshwar was here, Janardhan was here. I do not remember their name. But once I saw who, I said, these are the people. Okay, because, the vision, the human vision is far beyond that of organs. Okay, I cannot remember the name Janardhan, Rameshwar. but I can really, see the image and say, oh, these are the people. Okay, many of you, probably in this particular participation might have seen, oh, this Salman is this person, oh, we know him. Okay, so that is what. So it's very easy to get the trends and so forth. Okay, data visualization is the use of human natural skills to enhance data processing and organizational efficiency. In fact, please try to understand data processing enhancement is possible through data visualization. Okay, so visualization, because we can take decisions very fast. If it is visualized, if I want to just see every student in the class and say who is attending, who is not attending, even my visual, I cannot see everyone at a time. If it is visualized, then I can easily get to know. I can take a decision now what to do. Let me give a break of 10 minutes, ask them to go to a canteen, have a cup of tea and come back. Okay, so that's what, probably I do mostly in my evening session, 4 to 6 and all. I'll just check it, what happens, after 1 hour. And I say, okay, that has a break and so forth. Sometimes we give a memory break. So this all happens with visualization. So visualization can help us deal with more complex information, enhance memory. Okay. Most people don't know how much about statistical data, basic statistical method are not in line with human cognitive nature. This is very interesting. What happens is, probably a lot of statistics is involved and suddenly you're lost. You're not able to visualize. So in addition to that, we should be also able to visualize the same, which we'll see shortly. Okay. One of the famous examples there is Anscope quartet, you can see it. Okay, it is difficult to see the law according to statistical method, but the rules are very clear when the data is visualized. If you just see the law of statistical method, sometimes it becomes difficult, but if they are visualized, it is very clear. We will see some of such examples. Now let me come to data visualization process. Here also we'll spend a little bit of time. So data visualization is the process of mapping from data space to graphic space. We have already discussed. We have to get a graphical representation of the same. So I want you to concentrate on the second figure below here. This is very much important to understand the process. Okay. The classic visual implementation procedure is to process and filter the data. You can transform it into expressible visual form and then render into user visible view. Please try to understand it. What we do here is, as a machine learning expert or a data scientist, we do process and filter the data. Okay, the first figure here, data. Okay. Then what you do, you convert it into an expressible visual form. Okay. So that is what we stop here actually. We stop here. But what it says is, we need to again render into UI, user interface. Because what happens is, whatever form you get it, say for example, you get a graph, you get a bar graph, even the user is not able to understand that. So you can give a better way in what should be the better representation for a user to understand, you can give it back. So here there are two transformations applied here. One is filtering, another is a rendering. So filtering will transform your data, okay, data space into the visual form. Okay, it is analogous to the visual form in the item registry. Whereas rendering will convert this visual form into a form which is understood by a naive user. That's what I said somewhere. It's very easy to say there's words called accuracy, okay, the precision, the recall. My customer is not interested. I talked about that, right? We're able to get that, but we have to again put it into the form where user can understand. So we have used a geographical information tool, GIS tool, to represent the same. That is what a rendering process is. So sometimes, the good benefits of your algorithm or your, the model is not realized if it is not rendered properly to the end user. That's why we always ask that, when you develop this particular algorithm, how it will be used in the real-time life. So that is possible if you have a rendering mechanism done. So simple way, that is what a data visualization process. The abstract way is, it is used to map the data space to a graphic space, and it has two transformations, filtering and rendering. Now, you will be very much surprised with this slide. Okay, and I'm again taking back to your particular first somewhere in the beginning, where I said that it is an interdisciplinary or multidisciplinary area. Okay, in fact, if you want to make a career in data visualization, if you want to become a data visualization engineer, then you need to master this technology stack. I'm not talking, one is a tool stack, which we'll also possibly discuss, a tool stack as well. But it's a technology stack, or you can say the basic knowledge, what you need to have it if you want to become a good visualization engineer. Very much surprised to say this, but see this. You should have a basic mathematics information, trigonometrical function, linear algebra, geometrical algebra. You know very well linear algebra is most extensively used today. But the way it was taught and the way it was understood was to do certain problems. But you really need to understand how it is used for data and of course data processing and so forth. Likewise, a little bit of graphics knowledge is also not needed, specifically with respect to Canvas, WebGL, computational graphics. Of course, graph theory people use it. Then please try to understand that whenever we talk about a machine learning, people only talk about these engineering algorithms. Okay, basic algorithms, statistical algorithms, common layout algorithms. But we require all the things to master to become a data visualization engineer. You have to know data analysis, where is data cleaning, statistics, data modeling. I think most of the things were covered. We also require very interesting called design aesthetics, which requires a lot of skills to master. It's not so easy. Okay, it doesn't come with reading or listening to lecture. It comes with practice. Okay, because I need to know what should be the color of my screen, what should be the color of my graph. Okay, whether I should follow a consistent color. Okay, so that interaction between the colors, changing of the colors, the cognition, everything is required there. And so a lot of probably people say that HCI also comes into picture there. Okay, then Visual Basic, you require some visual coding, interactive languages so that you can represent it. Visualization solution, correct use of charts is a very important thing. Like you cannot use any chart for anything. So based on the data, based on the context, based on the trends you want to observe it, you have to select the proper chart. So this is a visual technology stack. We say that this is nothing but the skills which are needed by a visualization engineer to master this, that is to become a master in this particular area. So he or she has to, be expert or be good a student in this particular technology stack, which includes basic mathematics, graphics, engineering algorithms, data analysis, design aesthetics, some Visual Basic as well as visualization solution to select the appropriate charts. Yeah. Now let us come to your most important thing. Like you may say, oh, a whole lot of theory is told, but here is the most important slide coming for you to practice is data visualization tools. Okay, I'm not going to do any programming here, but just to display some of the things. Okay, R language is used for visualization. ggplot2 is used. Python is also used. Most of these things are used in academia. Okay, we also use a lot of Python for this. We'll also discuss about it. And of course, most familiar tool for ordinary users is Excel. People used to draw a lot of graphs using Excel and so on. However, we have a lot of commercial tools available, which includes Tableau, Find Report, Power BI, etc. There are other tools as well, which probably I have not explored all. You can go through it. We have D3, data-driven documents. That is D3. We have something called high charts, E-charts. I think Leaflet we have seen once. Vega is there. Power BI we have, of course. It's also displayed as a commercial product. So here, these are some of the other tools for visualization. So my, of course, advice is probably you can start with a Python libraries, or you can start with R language initially, and you can go towards information visualization, and you can slowly proceed towards other tools as well, where you can go for a scientific visualization. You can write the piece of code there in case of Python itself to get your scientific visualization into picture. Okay, there are very strong libraries available there, which you can start exploring to really practice this data visualization. Okay, I'll talk about some of these libraries which are used in Python. Okay, you might have heard about this matplotlib and seaborn. So most commonly used library for a 2D plotting in case of Python is matplotlib. Okay, so it is a commonly used library used for 2D plotting. It is basically used for 2D plotting. Okay, and the very interesting thing is it can be used with all dialects of Python. Okay, when you talk about any dialect of a Python, probably if you see, we have various dialects available today. It could be a Python ID, it could be a Jupyter. So many things are there. So this matplot library is supported with all dialects. Okay, so the methods of matplot are used to generate bar charts, histograms, scatter plots, pie charts, etc. I'll of course summarize that in a single slide so that we can start practicing over it. Okay, and you might be already practicing. But surely I would like to talk about the seaborn, which is a very good data visualization library in matplot. Okay, because 2D plotting can be done with any, any random data. Okay, any raw data, you can take it, you can do the 2D plotting. But actually, we are not doing that, right? We are talking about data, we are talking about data cleaning. Okay, then we are talking about data processing, then we are talking about data visualization. So we require some of the things to come together. Okay, we want some of the things to come together. When you want these things to come together, then we require this particular library called Seaborn. Okay, so Seaborn data visualization library is based on Matplotlib library. These are, of course, Python libraries. So it is integrated with standard Python libraries and are generally used for data analytics. That's what I talked about. But this includes NumPy as well as Pandas library. Of course, people have started using directly. I think you know that people might have discussed. People have started directly using Anaconda, which has everything in that so that it is very easy. But it's very heavy on the system message. We do not use it. And I believe people know the stack of it. Okay. And I think, people at least from computer science should build up their own stack so that, they can save a lot of memory and you can do a lot of processing very fast. The stack is like this. I'll just probably take a minute and just summarize that stack. You have a Python, basic Python. Over and above, you can install libraries like NumPy and SciPy. So you have basic Python, over then install NumPy, you install SciPy, and over that you go for Pandas. There is actual data inside the library which is used for data analytics with a lot of data frames possible with Pandas. Okay, so you have a basic Python, you have implemented again over that you had an NumPy, over that you had a SciPy, over that you had Pandas, and over that you can get your Matplot and Seaborn. Specifically, you get a Seaborn. So that what happens, it realizes the NumPy, Pandas, and that is Seaborn features together. That's where it helps. Okay. So if you're using a Jupyter framework directly, you can use pip _ install to install it. Or if you're using a command prompt, you can say easy _ install it and check it. And you can start using those particular methods on the data. Yeah. So let us see installation of libraries. I talked about it. You will also require NumPy, SciPy, Pandas. Over and above, you can install this Seaborn libraries. Basic charts, which can be drawn, of course, in a couple of slides. I just cover it because I don't want to spend time on it because you might have already drawn several times. So you can create a scatter plots which has, the point, that is the points which are there. Okay, to know, probably you might have done clustering and classification, all those things in your sessions, where probably you can get to know those particular clusters, very good clusters, the patterns you can get to know if you have a scatter plot. You can say, okay, some points you can find it here, some group of points you can find it here, somewhere few points are distributed. You can make your cluster very easily. Okay, so you can use x.plot.scatter. Okay, that is used for scatter plot. Then you can also use line charts. Okay, using this plot.line. You can use histogram. Okay, so that you can have a lot of buckets there available to identify the frequency and so forth with respect to bar charts and this. But most importantly here, the plot, which I want to tell you, which I said that once you do the exploratory data analysis, you can still visualize it. Hope you remember that. So once I do EDA, I might have not done an algorithm, but I want to know the basic features of the data. I want to know the basic features of the data. In that case, what I do, I tend to use box plot. Okay, so the box plot, what it does is, it is very important plot here. Probably if you know very well, maybe people have done the descriptive statistics. Okay, once I get my data clean, okay, whereas I have removed the not null values and all those values, then I want to do the basic statistics onto that, and I want to see what is this data talking about, the basic characteristics of the data. I use a box plot. Because in box plot, what I do, I get what is the minimum value, what is the maximum value, what is the mean, okay, what is the quartile 1, what is quartile 2, what is quartile 3. I'll get an interquartile range, and I'll find some more points which are, away from these particular, okay, the cluster. So we get outliers from that. All those things, you can get it through box plot. So first thing is, to know the actual intuition into the data, what this data speaks about it, you can have a box plot. And if you have some categorical data, you will have separate plots for every categorical data as well. So box plot summarizes the distribution of numerical feature of one or several groups. It provides a better way to visualize the numerical data. So here, numerical data can be better visualized using box plot because surely it has mean, okay, variance. It has talk about the quartile 1, It talks about quartile 2, quartile 3. It talks about interquartile range. So I said it is very effective to go with this particular box plot. Fine. Now let me come to the very interesting part called churn of faces. Okay. Now here, if you see talk about this particular other representation, you talk about, of course, that is visualization of a single variate or maybe two variable data representation or few. But when you talk about multivariate visualization, okay, many variables put together, then probably you require a churn of faces. You require churn of faces. So we will talk about this particular very interesting part of this particular thing. And I know probably you may be more interested to know this particular thing. You can just probably go through this particular very interesting paper on churn of faces by Herman. Okay. So here we'll talk about some of the research. There is some of the visualization aspects which we use it. Seems to be some problem.
Hello, Salman sir. Hello.
Dear participants, please wait for 2 more minutes. 2 minutes.
Your speaker.
అంతేనా
No, by default.
సార్ అది ఒకటి స్పీకర్ ఉంటే వాళ్ళు వస్తారా Sir, Moiz, sir, audio is not coming, sir. You are in mute, sir.
Yeah, am I audible now?
Yes, sir.
Sorry for that, because
Yes, sir. Audible, sir.
there was some. Yeah, interesting concept is turn off faces. Sorry for that interruption. You will of course like that, because probably this is two angles here. One is, I can say, an application angle. Another is a research angle. Okay, probably I'll open up the space. I'll tell you everything what we did here, and you really enjoy that. Probably we can also refer some papers onto that. People are interested can do it, because people started liking this work. Okay, so here what we do is actually we take many variables, multivariate, and we want to visualize as a human face. Okay, some of the features are as a mouth feature. Okay, my mouth may be closed, maybe open, maybe broad. Okay, some features may be talking about my big eyes. Some features, I do not have hairs, maybe that is one feature. I may have a cap, that may be a feature. Okay, so this Herman, what he said is there are 17 features that can be mapped. In fact, we at our university were discussing, it could be more than that as well. Because one of our faculty was saying that I can have a figure like this. This is also a feature. And you know very well, there is something called China faces. You can explore it. Okay, only for this sad and happy mood, we have about 48 representations. Okay, you can look into it. China faces. Okay, I'm happy, I'm sad. Okay, only these sort of things. There are 48 such faces. I think people are very good at emojis. Okay, so but I want to use that to visualize my data. Okay, I think you are understanding that. So what you have to do is I have to identify the relevant features before visualization. Okay, so that I can map to this. So R directly provides that function called faces. Okay, in R you can use that function called faces, and you can map your features to these particular 17 features and visualize it. In fact, the very good concept with respect to both R and the Python is nothing but we may not require all 17 features. I have only 5. You know very well, you might have seen that padding concept in Python, where it takes that 5 features, you repeat again into the next 5, repeat another next in the 5, 15. The first 2 are again added to 17 automatically to visualize it. Okay, so that is what it is used. You can know, but you need to really decide that which feature has to be mapped there. That becomes a challenge. So we'll talk about one such particular work which we did it, and probably when time permits, if you're interested, you can go through this paper as well. What we do is we are doing, actually that's where the very beautiful thing, like sometimes people outsiders ask us, because I had a software engineering group. I said, what research can be done in software engineering group? In fact, a lot of data science, a lot of machine learning, a lot of visualization, a lot of analytics is done here. So one such particular work, probably where my last student used to work, who completed his PhD, he used to work onto this. Okay, he used to work on that smells, but I used to work parallelly with him on visualization. He didn't work on visualization. Okay, but we used to use, probably we both used to use his data and so forth. So here, probably I'm just switching away a little bit. I'll not discuss all these points. Probably it is only for reading. Only a few points I'll take into picture. So the entire work, what he did was to identify the smells in the code. We say a particular code which is not easy to modify. It has a lot of anomalies, inherent anomalies. It may not give an error. It will execute perfectly. Yet it will have a lot of anomalies in that. These anomalies are said to be smells. We say, okay, it smells bad. Okay, it's a smelly code. So probably his work was to detect the smells using the machine learning and all these sort of concepts. So what we want to do is actually, we want to visualize that smell. I'm a programmer, and I have written a method in that method, how bad it is written, I have to visualize. Now, the method may have, now you may be very much surprised, what could be the features of the method? Okay, you might have studied some metrics in courses like software engineering and so forth, where say lines of code is a metric. So can that be a feature? So, we have to identify all the method features. And can I map to the 17 features and visualize it as a face? Maybe a bad face, which is written, which is very smelly code. The Pandit has to improve it. So that was the work. Hope that if you have understood that, you'll enjoy the coming slides. So several tools and techniques are available in the literature which helps detection of the smell. Now, what happens is there are tools. You say, once you put that particular code to that tool, it says yours is your code is having a particular data smell. Okay, that is a long method smell. Okay, so it has a long method smell, but probably it has a long method smell. It is very difficult for you. Instead of that, if it can be visualized, okay, that was our concept, and we visualized it. Okay, so a few other tools helps in extracting various metrics of the code. So here I would like to tell you, because this workshop also talks about applications. I have seen in the title. Okay, so what we did is nothing but we have initially worked on metrics of the source code. There are some tools available, no doubt. And for your surprise, this was work on object-oriented, that is metrics. It was not structured metric. So roughly we had about 81 metrics. That is for your surprise. 81 metrics were there. They were, very well in object orientation. We have a project. Under that, we have a package, we have a class, we have a method. So we had certain method level metrics. We had a class level metrics. Of course, class contains method. When we talk about a class level smell, it should also contains method. Then we have a package, where a package consists of many classes. So a lot of containment relationship come into picture. So for a project, we used to get about 81 metrics. And let me tell you, in this entire work, probably about 120 projects were, taken. We have prepared the data set. It's a primary data set. Okay, we have prepared the data set in the lab. And you'll be very much surprised that, if I remember correctly, we have about 5.5 lakhs methods. 5.5 lakh method. So we had 5.5 lakh object into 81. That was the metrics we got. Now we have 81 features, and we want to visualize where my header said that you can only visualize 70. So there we got a challenge that, probably might have studied a lot of techniques in this workshop till now, where they were talking about, the feature selection or feature extraction, or, probably the feature, reduction. Okay, we have to apply all those concepts. Okay. So here it says that why we need visualization is nothing but severity of the smells is often not known. It may say, okay, because, if it is suffering from one smell, okay, to how much extent it is smelling, how much extent that method is written bad. If it is visualized properly, I could get to know. But there are no such particular exact tools available to do that. Okay, so here probably in this next slide, we have two method level code smells discussed, which is long method and a feature env, are visualized using churn of faces. Okay, I think everybody can understand long method. There is we got this example. Some of them says that you should not have more than 20 lines of code in a method, otherwise it is classified as long method. Somebody says 50. But there's a problem with the threshold values. But still, I want to visualize it. Okay, let us see that. I don't want to discuss this, but I want to just specify that. Second point I would like to specify, code smell detection techniques. Okay, there are so many code smell detection techniques. Okay, so what happens is we took that 74 systems. The last point is important. Herman invented churn of face to represent multivariate data using human faces. Parts of faces such as mouth, nose, eyes, ears can represent values of certain attribute. You may say, okay, eyes 2, nose, mouth. How many are there? 1, 2, 3, 4. Okay, maybe if I say eyebrows, 7, but all you are saying 17. There are so many things in that. We'll see. Okay. Now here what happens is the mechanism for rapid application development, because what happens in this software industry is nothing but there are a lot of competitions. And probably if you're able to modify the things very effectively, it will be good because you have a lot of maintenance-based projects. So what happens, can we identify anomalies in the code? So that what happens tomorrow when you do the maintenance, it can be done very fast. So there are certain code visualization tools. Okay, Like, some people use J deodorant. I think you might have seen it. What it does is it highlights, maybe you might have seen a yellow background highlight, which is done to identify some smelly methods. Okay. But in those particular methods, it requires a lot of human intervention because it will not say the severity of that smell. It even doesn't say, most importantly, which type of smell it is. Okay. So here, but what happens is, why this field is important in this case, nothing but because today we talk about agile methods, rapid application development. So because of what happens is, people often ignore smells. They said, okay, rapidly develop it, deploy it. Okay. But it becomes very difficult for them when they get a maintenance request because it was suffering from smell. So here what we did is, if it can be visualized, okay, the design anomalies, okay, we did on the source code. Now we are doing at the design itself. Can we identify these particular, anomalies and visualize it in the form of a faces so that appropriate step can be taken there and then itself, right? So that was the total background, and that's the reason I discussed this. So I will again skip so many things here. So this was okay, what happens is, whenever there is a smell, whenever the code is smelly, we have to modify that. Okay, so that we should get the same output. So that is said to be refactoring. So we have to apply refactoring. But interestingly, for the understanding of the people from this particular workshop, I would like to go through the second and the third point. So we are discussing two smells, long method and feature or method level smells, which are either identified using knowledge-driven or data-driven approach. Here you need to understand this point. Now, you remember that I said that we have collected the data, okay, based on the metrics, method level metrics, class level metrics. So we got a data. So we can we can identify the smells using data-driven approach. Okay. Then next we have a knowledge-driven approach. Some people in the literature gave some rules also. Okay, some threshold values. Threshold values are, if the coupling between the methods is greater than some value, it is suffering from this particular smell. Okay. But what happened is, we said that we got all of them together to map the facial features for quick visualization. We use both the things together. Okay. So I already talked about long method, which contains many lines of code. What is the issue? If it has difficult to maintain, understand it, and it's often complex, difficult to modify. So they say they use a particular policy called extract method. Extract some part of this and put it into the other method. And a feature envy, a method which is tightly coupled with other classes, then its elements. So here, feature envy, what happens? You are having coupling with the other classes more. You are calling other classes more rather than itself. So of course, this becomes a maintenance issue, because if something has to be modified, the effect will be there at many places. So for that reason, we need to identify that and refactor it. Now here, for your understanding purpose, you may be very much surprised. Some of the metrics I have displayed here for your understanding purpose. So sometimes we use tools to identify these metrics. Sometimes when some tools were not there for some of the metrics, we wrote our own bunch of code to identify these metrics in that, so that we had a huge data set. So that is to say, I'm actually telling you that there is a way to create the real data set. So that's where what happens is, you can really, otherwise what happens is, if data is not owned by me, it is very difficult to get the insights into the data. Or I need to understand the data very well. And these are the two drawbacks with respect to the machine learning concepts today. Either people use some secondary data without understanding it. Okay. And nobody wants to work on the primary data. Sometimes people feel, how can data be constructed? So here I'm showing you some of the methods, even with a very abstract concept of a source code at the method level, you can get your metrics. Lines of code, everybody knows it. We have cyclomatic complexity as one of the things. Max nesting, it represents the maximum nesting of a control structure in a given method. Okay, how many nestings are there? Whether this method is calling another method, and so forth. Number of parameters, number of access variables, number of local variables, access to foreign data providers, coupling intensity, locality of attribute access. I said that there are 81 such metrics. So we have to identify and compute that metrics. We have been putting a lot of things, and some probably maybe another 6 months we'll get a huge data set which will put it onto the open data source for people to use it. Now, there are some of these particular rules which are there. Now, very interestingly, here I would like to explain you some of the things. See here, okay, these things comes later, but I would like to explain you here itself. We said we have 17 features. Okay. Now I would like to show you that we had 81 features. How did we, compute the 81 features? We did not, apply any direct algorithm there because we know the domain very well. Okay. What constitutes a long method? We know the domain very well. So what we did is, since method is at the lowest level, when we did for method, because in this paper, we only talk about a method, not even a class. Of course, in another paper, we talk about a class as well. So when you talk about a method, so it doesn't require characteristics of a class. It doesn't require characteristics of a package. It may require the lowest level thing. So what we did is initially we removed that. Okay. Still, we were coming up with some of the features which are more than 17. Okay. Then what we did is we went to this particular, that's what we are talking about. We have fused, we have done a fusion of data-driven as well as, okay, the rule-based approaches. Okay. So we took that particular data, we removed the irrelevant features based on the domain because the package level metric will not contribute to the method level metric because we are doing at the lowest level. So we remove that particular thing. So finally, when we got this particular metrics, there were of course more, which we'll see in the coming slide. Then we want to reduce it, further reduce it. Then probably we have seen all this particular, if you see, some of the people in the long method have used LOC method. Most of them use the LOC method. So this was taken as the first priority. Okay. Then we said cyclo. Cyclo was used in 2 or not used here. That was a second priority. So based upon that, we have prioritized them. Okay. And of course, then finally, then we have also even computed a manual intervention to remove some of the metrics which do not constitute, which do not, of course, make any impact on the long method. Thereby, we got those particular features. So this sort of process was done to arrive at it so that we can visualize that phases. That's what, the results were very good actually. So similarly with respect to feature envy, because I don't want to keep you very dark till this moment of time so that you see the result. That's what the visualization workflow. Of course, I'll just display that paper so that you can go for it. So this was started like this. Which smell I am concentrating at it? Because I was not looking at all the smells. I cannot start in a large scale like that. So if you see in the initial contribution, we looked at only 2. One is long method and feature envy. That's what we have identified. Collection of heterogeneous system, because really we need to really test it, because this cannot be a theoretical concept. So we have collected some 74 Java systems and so on. Okay. Then we have evaluated the metrics. I said 81. So we got 5.5 lakhs methods. Then we labeled it. I'll talk about this labeling process. These metrics will not tell me whether it is smelly or not. Right? So what we did is there are some tools which only say that whether this code is smelly or not. So we have given the labels for that. Okay. But again, we did not have, every time we did not have a that is your consistency among tools. Like sometimes it happens one label tells that it is smelly. Well, one tool tells it is smelly. One tool says it is not smelly. It happened in a few cases. Then we, of course, went into the data. Of course, the experts went into the data and corrected those labels. I think I'm explaining, the real application. How do you do it? And of course, probably if you talk about, the most of the things which comes today, okay, I'm telling open at this forum, people, just to take some data set, run those machine learning algorithms, okay, plot the things. And they say we got this particular accuracy. But that doesn't give to the real meaning of it. Hope you're understanding it. Even we did not believe in one particular tool giving that particular label. That this, it is suffering from this particular feature and we smell. Some of the tools says it doesn't suffer. So we have used some, probably 4 or 5 tools. And in some of them, there is everything is yes, we took it as. But whenever there was no, cognizance among them, we went into that code and checked it and corrected the label. And we, of course, went to particular analysis as well that some of these tools cannot detect these particular smells properly when the code side is this or when the code domain is this. So that was a labeling process. It requires a lot of time. Then feature ordering. As I said, we have taken first all the features, then we have removed the features which are not relevant to the method. Then probably what we did is nothing, but we took because we said fusion of even the rule-based approaches. We have identified the active, that is the features from the rules, and of course prioritize them. Then whatever features we got it, we mapped it to the phases. And we again mapped it to the order of the priority. And we visualized those particular phases. So that was the concept. And probably it works for every system. May not be only system of a smell. You can just remove that word called defined desired smell. Okay, heterogeneous system is your data. Okay, Then this, of course, this particular thing, evaluate code metrics is your features. Then you have a label. Then you have future ordering. Then, of course, this is a mapping attributes to the facial features and visualizing. Yeah. Just some of these things which I want to say here. Okay, I'll of course brief up because short of time. 74 projects are initially proposed, which resulted in 419,095 objects that represents methods of the classes in the project. We have used sampling because we cannot do with that particular data. Sampling was done. Each of the resultant data sets of 417 objects later. Okay, most relevant features are initially computed using information gain. We also used information gain. Okay, we did a lot of computation there. We did an information gain. Then again, in addition to that, we have also used those features which are there in the rules, and we gave the priority. That's what it says, the last point. The fusion of knowledge and data-driven strategy helps in selecting the best possible features. This is, our conclusion with respect to the data, what we are working on it. Okay, so that gave a best possible features. There could be various, feature extraction techniques available can be used, but you need to see whether it is appropriate to that particular domain. I think now you'll be happy to see this. Some of these particular smelly long methods are displayed onto this particular slide. Okay, so if you see, these are smelly. Right, we are still working on it. I'll tell what happens here. So here, if you see my noting at the bottom, the common features of the smelly long method is that it includes horns, pointed caps, okay. I think I'm audible. Okay, pointed chords and spread mouth. So if you see here, there is a spread mouth here. Okay, there could be this pointed cap, which is pointing towards the ear. Okay, and of course, they also have horns. These are the things we have taken in the smelly long method. Non-smelly long methods, okay, they are not smelly. So the common feature of non-smelly long method is the red color domination. It doesn't contain horns or the pointed caps. So here mostly, of course, not in every cases, but we have seen there was a red color domination in this case. There was always a red color domination in case of non-smelly long method. Then of course you will see there was another type of smell called feature envy method. Okay, of course I'm not saying that we got 100% visualization correctly. About 95 to 96% was correct, and of course we got another way to improve that also. So it is observed that these methods, smelly method visualization includes pointed nose. You are able to see pointed towards eyes. Okay, the pointed nose and broad open mouth. Okay, these are the two common features we are able to see in this sort of. So except in this case, we didn't got a pointed nose. Otherwise, in 222, 224, 226, 228, 281, everywhere we got a pointed nose. Except in this particular 320, it was a pointed, but if you see the size of that is different. So that means to say that if you see, so many features are mapped here. Okay, and there was mostly an open mouth. If you see, open mouth in every case. So some of these features you identify to, of course, plot that, and it became very interesting for us to visualize it. And probably we are going towards making a video out of it as well. Okay, we are in the process of that. Non-smelly, always we have seen that non-smelly is always it has a red color domination. Okay, here it says the most common features of non-smelly feature envy method are red color domination and mostly a normal face with no pointed nose and broad mouth. Yeah, so we can see this particular, let us maybe the footer where this paper is their method level code smell, churn of first visualization, learning and analytics intelligent system book series, a chapter there where you can check it. Okay, now probably if you see this sort of visualization will help you a lot, but I think you might have understood that it is not all about visualization. You might have seen that process. Okay, that process has to be adopted. Okay, then only probably get into the insights into data, because you need to really understand the insights into the data. Otherwise, the visualization becomes very difficult for you. I think you are able to map whatever I said earlier. Yeah, I'll also discuss last one called visualization of smelly classes. Okay. So refactoring is needed. I said refactoring is nothing but modification of that code to remove that particular software. Now, what happened is in the next level, we went towards a class level smell. When we discussed this technique, we were very much, the hard coded. Okay, we are very much hard coded. We are only talking about that. When we came to this particular concept, we generalized the things. I'll talk about what we did is. So what we did here is nothing but we did not do the rule, because there were, of course, no compromise between the rules. Some of the features were different. So we went for something called coefficient of variation, okay, and information gain. So I'll show you in a coming slide how it was done. This is another way where, probably you can visualize the things very well. Okay. So it is not only, I think you have understood, didn't talk about visualization also. It talks about so many things actually, till you reach visualization. And if you could see that mapping of the visualization process, where we said once we do the analytics and all, or once our model is built, you remember that figure, you had a reporting visualization concept that exactly came into picture in this particular thing. Okay. So here we have used, in case of when we went to visualization of smelly classes, okay. When we went for visualization of smelly classes, so what we required here is nothing but we use coefficient variation as well as information gain. Okay. So here we have used two classes for experimentation, but we have proved that it works for all classes, that is smelly classes. One, we talked about a God class, just for your understanding purpose, not needed at this scale. So it's a large class which realizes many responsibilities. It's a God class has many methods. Okay. Issue is it is difficult to maintain and understand because it's very complex. So how do you remove that problem? Divide into subclasses. That is what refactoring says. And we have a data class. It's a class which contains only data with getter and setter methods. It should only have get method, set method. Apart from that, it does not supposed to have anything else. Okay. But it violates design principles. So what it says, you have to move method and extract method. We'll talk about it. Yeah. Now you see this particular figure. I would like to know you to concentrate on this. This is another way where we generalize the things. If you remember that, one such way probably you might have appreciated was this flow. Okay, though the title is mainly visualization workflow, but it makes sense for your learning, how do you do the things. Likewise, we went for a very generalized one with respect to the smelly class visualization workflow. Hope it is visible. Okay, so what I do again, start with define candidate smell. What I want to do it, that is what is more important. So maybe my candidate smell could be the God class or a data class. Okay. Correct software projects, which is data. Evaluate the metrics, you know very well. We did it. Label decision variables using tools. We also discussed that. So I put into some of the tools and do it. Okay. Of course, here you can modify when there is no compromise among tools. We do manual validation, manual adjustment of that particular labels. Now coming to the next part. Compute the information gain of the features. Please see this. Compute the information gain of the features. Compute the coefficient of variation of the features. We did this. Okay. So based on that, we are able to identify the outliers, which are of course no more matching this information gain as well as coefficient of features. We are able to identify, refine that is remove that outliers. Then we refine the features further. Okay. So we use two concepts here. So first we did the information gain. We arranged as per the increasing order of the information gain or decreasing order of the information gain. Then we computed the coefficient of variation. Then we mapped. Okay, and we arranged it. So we have able to identify outliers. We removed it. Even after that, we had some one or two extra attributes which were crossing this particular limit of 17. So then what we did is nothing but we identified whether they were relevant to that particular defined candidate smell. So once we are okay with that, then we have mapped these particular features to the facial features so that it can be visualized properly. So that was the concept which is used, and now here we got it. And here I would also like to tell you that how did we compare with the other smells or people who already worked on it. Smelly God class, it is observed that smelly God class are either dominated by red color faces or includes big faces with white caps or horns. Okay, though only some 9 data items are displayed here. This was worked on all those particular 470 objects after we did that sampling, right? So here, these are the features what we observed in most of these particular visualized thing. The smelly God class are either dominated by red color faces or includes big faces with white caps or horns. And that was visible in this particular data set. And likewise, we got a non-smelly God class. It's very easy for you to identify the features. It includes green hat domination in non-smelly classes. So in case of this, if you see, there was no commonality. There we had a red color domination. Here we got a mostly like a yellow color face like this. Right. Most importantly, we found a green cap in case of this. So probably we are going to visualize now both together. A particular method will have a particular class may have more than one smells. So we would like to see that hybridization, how it looks like. Okay, that is the work we are still going at, of course. In fact, people appreciated this data set, how it was made. Okay, because we are into the data set. In fact, we also remember some of the methods which are written. Okay, yeah. Then smelly data classes. This was non-smelly God classes. This was about God classes. This is smelly, which has a problem. Non-smelly, which doesn't have a problem. No anomaly of a God class in that particular class, right? Next, we have a data classes. We were talking about the data classes. So smelly data classes, we got this. So you see the observation. It is usually observed that smelly data classes are either dominated by red color or include big faces with their white caps or horns, and these caps or horns are not in white color. Oh, that is very interesting. Here, if you see, these also God classes are either dominated by red color faces or include big faces with white caps or horns. And here we got it, same thing, but these caps or horns are not in white color. Even that was noted here by seeing the entire data set. That is what we got it. So we are trying to work out, can we make these particular statements, what we got it from data set as generic one. We are doing that. Okay. And I'll tell you what other things we are doing it very shortly. Then we talk about non-smelly data classes. This is also published. You can see this. This is very interesting. Probably if you can go to this paper where it gives you a very generic process. And if you are interested in applying for your data set, I suppose it should work. Okay, the details are given, though it's not published at a very good place, but because of the continuous force from the CSI people, we put it there for people to access it. It's open access, you can see that. Class level code smells and of face visualization. And the other one was method level code smell. But this paper talks about very generic things. It can be applied to any domain. And you will really start probably enjoying it if you can apply it. It's very easy as well. Okay. Because there is a faces method already available in case of R. If you want to do Python, there is no method specifically available with respect to faces, but there's a script already written which is available on Google. You can write it and you can start visualizing it. It's very interesting. So here in this case, in non-smelly data classes, it is usually observed that green head dominates the non-smelly classes that we saw it. Even a white head is seen, but it is usually observed that in non-smelly classes, it is white in color. That's what again we got to know. So this was very common for us, where it was either a green color domination or mostly it was, even the hat was in white in color, was for most of the non-smelly classes. Okay, so the conclusion was this like this in this. Okay, it's not a conclusion of my talk. But code smell detection is an important activity, forget about it. But third point is important for this particular audience. In this paper, both knowledge and driven strategies is used to identify most relevant features. But later on, we also went in identifying that is using two things. One is coefficient of variation as well as the information gained together. And that helped us a lot in this particular contribution. Now we are working at various other things. We want to put a video analytics for this particular smells, number one. Number two, of course, we also came up with an idea where probably we identify some chunks of the code, which could be at the method or which could be at the class level. So what happens here is, it's a good method. For example, it is non-smelly method. So we are also trying to identify, can we get some distance metric? Because you study various algorithms, right? You might have studied k-means, KNN, and so forth. So we would like to get that with respect to visualization. A best method, a best class. Okay. And we are, of course, we're talking about, God class. So for example, we have a particular visual representation, which is non-smelly data class. Okay, now here what is happening in this case, in our classification in this case, it's mostly binary classification. We are also planning, can we get through visualization, okay, even the membership? I'll say that this is smelly, but its membership is 1/3. Okay, it is only 33% smelly data class. So this we are going to compute with respect to the distance between this visualization picture. We would like to get a lot of video analytics over that to make it more easier. So that way, probably this particular thing, this is one type of visualization we were working on it. So I thought probably I could share with you. So, but if you see, just to conclude the things that visualization is at most necessary. Probably might have seen there. Again, I'll take back there so that you get, if you have really followed my lecture, then you will see some of the things which we have seen earlier. I'll talk about here. Yeah. Here we said that once I do a data analysis, of course, I said that we have some of the methods like visualization called box plot, which can be done even after your EDA. It's not necessary visualization comes here only after models and algorithms. So you remember that our model was there, our algorithm was there. Then you could again visualize it. Okay. Of course, you have seen only one dimension of visualization. Sometimes what happens is like, since we already did that particular feature analysis well before, we don't do it. So if you are not doing that also, then probably what you need to do is you need to really play with your features. Yeah. So you need to really play with the features so that you get a proper visualization of it. So what happens is you need to vary the features if you have not really worked inside the features so that you could visualize it properly. Yeah. So you have to do this particular stack if you want to become a data visualization engineer. Otherwise, also, if you're not interested, then at least you can do the information visualization without going through all those things, but practicing some of the tools. But basically, you need to get insight into data, and once you visualize, you should appreciate it. So what happens probably, again, to conclude the things, it is very easy for me if I know which features are dominating rather than seeing the textual data and saying that this is a smelly long method. Okay, that's where the importance of visualization in case of machine learning and data science. Okay, so there are some references you can see it. So that's what I thank you, and I'll take some questions if there are any.
My dear participants, please, if you have any questions, please interact with sir. It seems questions are not posted as of now in the chat box.
Mm-hmm. But please see that you visualize the data, because most of the people just stop with precision, accuracy, recall. I have reached.
Yes, sir. Yes.
Okay, I have reached very good accuracy. Okay, I am telling we did a consultancy where my company is not at all interested in accuracy. Yeah, what I will do with accuracy? I have to show it to the government. Then we have to use that GIS tools and put that objects there. Then he came one day, he was IPS officer. He said, yeah, that's great. It is correct. Okay. So visualization is necessary. So you may not go up to that level, but after every analysis, plot it. And I think you'll appreciate this ton of faces which we have been using. In fact, we are also working towards increasing the features from 17 to maybe 25. Because one of our professors was saying, I'll have this sort of image. I'm sad. Okay, and now I made my students to do some work. Once they enter the class, okay, it will display on the screen. He's sad today. Though we are not getting very good results, we are getting some 80% correct. Because the students say, no, sir, I'm happy today. Maybe I pretended like that. Okay. A lot of interesting things are there. Probably, I think you might be wondering today that, this is also an area where can be explored a lot. Okay. So, lately we started working on visualization. So, like my colleagues talked to me, right? What are you visualizing today? Okay. So that's very interesting aspect of it. So I request you to please do it, because these workshops are really good. And this pandemic has opened so many features, like so many workshops are being conducted online. But really we need to do it so that we can do something. Yeah. Okay.
Dear participants, you can unmute yourself and you can interact with sir.
Okay, I think they are done. I'm standing between them and their lunch, probably.
Yes.
Yeah. Okay, no issues. Yeah. Yeah.
It seems they have not posed any questions yet.
Good, they might have understood everything. Yeah.
No doubt, sir. It's very sure, sir.
Yeah, that's good.
Thank you very much, sir. In fact, the way you started our lecture today, that one can take the profession, this data visualization. I really felt very happy, sir, so that there is such that much importance is there for this, no doubt.
Lot of potential. Lot of potential.
Yes, yes.
Yeah.
You made that statement very clear. In fact, it's a very important note for everybody, sir. In fact, it's a profession.
Good.
Thank you very much, sir, for your kind acceptance and sparing your very valuable time. And no doubt that the participants who were very, very attentive. Every word was very important. In fact, as we have given more insights, even to think and even to work for their future work in this direction, even for their research work.
And they're open. They can take our work, continue in that direction.
Yes.
Just follow that. And you can do it. Both. At least that journal paper is open. You can just type it right now and download it.
Yes, sir.
Yeah, that can be done. People can follow that. And if something is required, they can also come and discuss with us. So we are working even in this situation 24/7.
Yes, sir.
Okay, you can as well discuss with us. Yeah.
Yes, sir. Yes, sir.
Yeah.
Thank you, sir. Thank you very much.
Thank you. Thank you.
Now I request our Madam Radhika to propose the official vote of thanks for this session.
Okay.
Good afternoon, one and all. It's my great privilege to propose vote of thanks for day 5, second session. And thanks a lot, Dr. Salman, Abdul, Moiz, sir, for giving us very interesting session regarding the visualization, where we had learned a great thought that in this area also we can have a research scholars, and the people who are trying, or else the students or research scholars who are trying to find in which area we need to start our research. So I think this is a platform where they have got a very new thought today, that in visualization where we can proceed and we can do something to achieve our research in a very good manner, in a unique way. Thanks a lot for sharing your knowledge regarding the visualization and the usage where we are using in the scientific 3D phenomenon, and need for visualization and how to process the data, and after pre-processing the data, how to represent that in the visualization. Today, I think we had known the importance of visualization in a very good way, sir. Thanks a lot for your presentation, sir.
Thank you.
Thanks a lot, Moiz, sir.
Thank you. Thank you. Okay, then I'll take a break.
Thank you. Thank you, Salman sir, for kind acceptance and valuable time, sir. Thank you. Thank you.
Okay, sir. Thank you.
Thank you, sir. Thank you very much.
Welcome, sir. Thank you.
Yeah, my dear participants, be back by 1:30 p.m. sharp. We'll have a very important session once again today at 2:30 by Dr. Vadlamani Ravi, which will be again on machine learning applications and research challenges. Okay. Okay, you can have lunch and come back by 1:30 sharp. Thank you, my dear participants.
Okay.
Yes, sir. It's fine, sir.
That's nice.
Yes, sir. Yes, sir. Yes, sir.
So how is the participation? How many are there?
Sir, actually 84 participants have registered, sir.
Great.
But around 40, 45, higher sir, 49 members are attending, sir.
Oh, is it a paid one?
Only 300 rupees, sir.
Oh, 300 is nothing nowadays.
300 is IST members, 400 rupees is non-IST members, sir.
Okay.
That too, sir, in 300, we have to pay 118 to the IST Delhi headquarters, sir, out of which.
Oh my God.
It is self-sponsored.
300 is nothing nowadays. It is peanuts.
True, it is
like a lot of content.
Yeah, it is self-sponsored program, sir.
Agree.
That's what. Sir, I have seen our resume almost briefing itself is there six pages.
You don't read everything. You pick up the important points, citations, etc.
That's what. Yeah. Yes, sir.
Yeah, and areas of interest.
Yes, sir.
In fact, that was updated in 2019 May. Now,
Oh, 19 May, sir. Okay.
19 May, now 1.5 years are over.
Okay,
I have to update that.
Yeah, yeah, yeah. Hello, sir. Hello, sir.
Yeah.
Sir, shall I share screen, sir, with your details for more 4-5 minutes?
Yeah, 1 minute, 1 minute.
Yeah, please, please.
Yeah, you can share. You can share, no problem. You can share your own screen. How are the participants? Are they interactive? Are they asking questions?
They are not much interactive, sir. To some extent, they are interacting, almost very less, sir.
Okay.
But actually, I think with this, people will try to get some sort of motivation to work in this direction. The people who are working, like, in this direction, they may, but still, they are not asking questions.
Yes, yes.
Except very few and very simple questions.
Yeah. So you wanted to share my screen?
No, this okay. This itself is okay, sir. First slide.
No, not this one. The other one, what you had.
Yes, I think
my face was there. Maybe that you can share.
Yes, sir. Yes, sir. Yes, sir.
2-3 minutes afterwards, we can start.
Okay, okay, sir.
Okay, shall we start? It's 1:32.
Yes, sir. Yes, sir. Yes, sir.
So you go ahead with your introduction.
Yes, sir. Yes, sir. Respected today's resource person, Dr. Vadlamani Ravi garu, who is Professor, Institute of Development and Research Banking Technology, IDRBT, Hyderabad. Our respected Director, Dr. C.V. Krishna Reddy garu, or one of our coordinator of this program, Dr. K. Rameshwari garu, the Dean School of Pharmacy and Management Sciences, the heads of various departments, faculty, and my dear participants, very good afternoon to all of you. Warm welcome to our session today, which is going to be very, very effective as we have a very experienced personality we have, a great personality we have. It's really very great opportunity to all of us. Warm welcome and very good afternoon once again. It's my really pleasure to introduce about great personality, Dr. Vadlamani Ravi, who is Professor, Institute for Development and Research, Banking Technology, IDRBT, Hyderabad. Sir has obtained his PhD in the area of soft computing from Osman University, Hyderabad, and RWTH, Aachen, Germany, 2001. MS Science and Technology from BITS Pilani, 1991, and MSc Statistics and Operation Research from IIT Bombay. At IDRBT, he is presides the Center of Excellence in Analytics, first of its kind in India, and evangelizes analytical CRM and non-CRM related analytics in a big way by conducting customized training programs for bankers on OCRM and ACRM, data warehousing, data and text mining, big data analytics, fraud analytics, risk analytics, social media analytics, credit recovery analytics, business analytics, like this. And conducting POC for banks, etc. He has 207 papers to his credit, which includes high impact fact journals, both national and international journals. Sir papers appeared in Applied Soft Computing, Asia Pacific Journal of Operation Research, Decision Support Systems, European Journal of Operation Research, Expert Systems with Applications, Engineering Application of Artificial Intelligence, Fuzzy Sets and Systems, IEEE Transactions and Fuzzy Systems, IEEE Transactions and Reliability. Like this, on in a very reputed and high impact factor journals are available. Sir has edited a book entitled Advances in Banking Technology and Management, Impacts of ICT and CRM, which is published by IGI Global ESA 2007. Some of Sir's research papers are listed in top 25 hottest articles by Elsewhere and World Scientific. He has an H-index of 35 and more than 5,358 citations for his papers. His profile was among the top 10% most viewed profiles in LinkedIn in 2012. Sir has recognized as a PhD supervisor at Department of Computer and Information Sciences, University of Hyderabad, and Department of Computer Sciences, Belampur University, Orissa. Sir has invited member in Martius Who's Who in the World, USA in 2009-2015. He is also an invited member in 2000 Outstanding Intellectuals of the 21st Century, 2009 and 2010, published by International Biographical Center, Cambridge, England. He is an invited member of Top 100 Educators in 2009, published by International Biographical Center, Cambridge, England. So far, 6 PhD students graduated under his able supervision, and 2 more are currently working towards PhD. So far, Sir has advised more than 60 MTech, MCA, MSc projects and 50 summer internships from various IITs. Sir is currently supervises 3 MTech students. Sir is on the IT Advisory Committee of Canara Bank for their DWH and CRM project, IT Advisor for Indian Bank for their DWH and CRM project, and Principal Consultant for Bank of India for their CRM project. Expert Committee Member for IRDA for their Business Analytics and Fraud Analytics projects. He is a referee for 40 international journals of repute. Moreover, he is an associate editor for the SWAM and Evolutionary Computation Journal from Elsewhere, International Journal of Information Systems in Service Sector, published by IGI Global ESA. Like this, Sir is referee in very good impact journals. Sir is on the PC for some international conferences and chaired many sessions in international conferences in India and abroad. Sir's research interests include fuzzy computing, neurocomputing, soft computing, evolutionary computing, data mining, text mining, web mining, big data, privacy preserving data mining, global multi-criteria combinatorial optimization, bankruptcy prediction, like this, many more in list. At IDRBT, Sir held various administrative positions such as coordinator, IDRBT, Industry Relations 2005 to 2006, managing editor for Journal of Banking and Finance, Financial Technology, IDRBT, and Springer. Coordinator 2006 to 9, convener IDRBT working group on CRM. Sir has conducted ACRM proof of the concept for 14 banks on their real data. Sir has established excellent research collaborations with the University of Hong Kong, University of Ghent, Belgium, IISc Bangalore, and IIT Kanpur. He co-authored 12 international EDPs of University of Ghent, Belgium, on ACRM to banking executives jointly with Professor Dr. Dirk van den Poel, University of Ghent, Belgium, in 2011 and 2012. As part of academic outreach, he is a guest speaker in IIM Kolkata's PGP program and an invited resource person in various national workshops and faculty development programs on soft computing, data mining, big data, funded by AICT and organized by SRM University, JNTU, University of Hyderabad, and even other most prestigious engineering colleges in India. He is an invited panel member, chair in several national forums like IBA and big data analytics in banking in India. He is a member of task force to set up to suggest changes to curriculum by NSDC and administered by NASCOM to develop data scientists. Further, he contributed to the roadmap for big data in India developed by DST. He is an external examiner for PhD in Auckland University of Technology, New Zealand, and Christie University, India, Mumbai University, IIM Kolkata, Vishwesvaraya Technology University, Pondicherry, and even more other universities. He was the associate professor at IDRBT between February 2010 to June 2014. Prior to joining IDRBT as assistant professor in April 2005, worked as a faculty at the Institute of Systems Sciences, that is ISS, National University of Singapore, April 2002 to March 2005. Like this, many are in list. I am skipping because of time limitation. With this, brief introduction, I really very happy and warm welcome to our session, sir. We really very great opportunity to all of us to have your session, sir, for your kind acceptance and your presence with us. Once again, thank you, sir, on behalf of our institution, my personal behalf, and my other coordinator, Dr. K. Rameshwaya, sir. Thank you, sir. Thank you very much. Warm welcome to you, sir. Thank you, sir. Over to you.
Yes. Thank you. Thank you, Dr. Janardhan Rajgaru, for the kind invitation, and more importantly, for the kind words that you expressed just now, introducing me. So I'm time conscious person. Already we have eaten away 10 minutes. You could have, in fact, should not have read so much about me.
I have reduced, sir, maximum.
Okay, thank you. So let me get on to the thing, the topic of today's discussion: machine learning applications and research challenges. So this is a topic very close to my heart. Let me get on to the outline quickly. Before we get over there, brief introduction, very brief, less than 30 seconds. I work for IDRBT, Institute for Development and Research in Banking Technology, set up by Reserve Bank of India. That's very, very important. It's the first of its kind research institute set up by any kind of reserve bank in the entire world. And I have of course, he mentioned already, I had the Center of Excellence in Analytics over here. I'm here close to 15.5 years. Okay, I work in various areas of machine learning. So this is the outline of today's talk. Introduce AI and machine learning, and then give some formal definitions. Then we get into a related field, data mining, and I'll try to stitch all these topics together and perform a kind of demystification in my own way, because a lot of confusion is happening. Sir, recording taking place?
Yes, sir. Yes, sir.
Okay, thank you.
Yes,
so a lot of confusion is taking place with respect to the coining of these words. So I thought whenever I speak on these subjects, I have a slide which will demystify the topics and buzzwords, and then put them in a proper perspective. And then we talk about constituents of data science and applications, and finally research challenges. And we have some conclusions at the end. So therefore, why one should learn AI and ML at all? First of all, machine learning is globally recognized as a key driver of digital transformation, and what they estimate is more than 5 billion. This number is, I think we have to, yes, more than 58 billion. The dollars are there. The market is available till the end of 2021 with respect to investments, and with respect to global ML industry, growing at a rate of compounded aggregate growth rate of 42%, which is phenomenal, and it will be worth $9 billion in the latter part of 2022. And the neural network market itself will be about 23 billion in 2024. The deep learning applications market in the US alone has been predicted to shoot from 100 million in 2018 to 935 million in 2025. So these figures are really mind-boggling, and that is the reason all of us are learning these things in a formal way with the launch of MTech programs, BTech programs in various universities in India as well as outside India, as well as this kind of EDP programs or FDP programs. So this is a kind of word cloud which tells you importance of machine learning and associated concepts. This is a very interesting slide. The larger the font size, the more is the presence of that particular concept. That is the idea, and that is how you have to interpret. So machine learning and algorithm are very much there here, and these are the important buzzwords, and of course associated buzzwords also there. So if one were to define machine learning in the formal way, then one has to take the help of Professor Herbert Alexander Simon. He is the only person who has won both Turing Award as well as Nobel Prize. He won the Turing Award in computer science, as all of us know, in 1975. But he also won a Nobel Prize in economics in 1978. Within 3 years period, he won 2 prestigious awards. So this person defines machine learning as learning is any kind of process by which a system improves performance from experience, which is very straightforward. And machine learning is concerned with computer programs that automatically improve their performance through experience. And this is what typically is experienced whenever we perform, whenever we try to implement a machine learning algorithm. All these things we experience. So if one were to define, yes, what is the constituting the intelligence or intelligent behavior, so much so, then one has to look into all these aspects in which human beings are very expert at. I will not go through each one of them, just to give you a glimpse. Think and reasoning. Thinking and reasoning are the prior important traits of human brain, and irrespective of the language or irrespective of the intelligent levels. And then use and reason to solve problems, learn or understand from experience. So if all these things are the attributes of human behavior, intelligent behavior, then the challenge would be how do we replicate that kind of behavior on the machine? And that is the genesis of machine intelligence or machine learning. And several other associated technologies came afterwards. So this slide I prepared from my experience. So machine learning has got different avatars. So the first one is supervised learning. In fact, it was looking very good, this one in the Word. Once it got converted into PDF, the things have become, background has become black. Anyway, the first thing is supervised learning. Second one is unsupervised learning. Then semi-supervised learning. And the recent candidate in this table is self-supervised learning, representation learning, reinforcement learning, deep learning, statistical learning, transfer learning. So in order to learn about each one of them, we would require more than a day. But if you want to put it in a slide and then try to do justice to it, it will be very difficult. But I'll try to do it quickly in a couple of minutes. Supervised learning means you have been given a data set of X matrix versus Y, which means the Y is the thing that is actually indicating what kind of label, class label, each one of the rows in the X matrix has got. Okay. Alternatively, it is for classification setup. If it is for a regression setup, then we say the Y is a continuous variable which will have a bearing, which will be depending on a set of independent variables defined in the X matrix. So there are a host of supervised learning algorithms developed in the literature, both from statistics family as well as from machine learning family. On the other hand, unsupervised learning means the y variable is conspicuously absent. So you have not been given y at all. You have been given only x, and then based on x matrix, where the rows are the samples and the columns are the features, you are expected to get some knowledge out of it. And there are various forms of unsupervised learning. The immediate things that we can recall are principal component analysis and then k-means clustering. Semi-supervised learning means you have been given a data set of both labeled data as well as unlabeled data. So unlabeled data is very small, and you have to figure out a kind of functional relationship or a similarity between unlabeled data and labeled data and try to attach labels to the unlabeled samples. That's a kind of challenging task in semi-supervised learning, and it is very useful nowadays. Self-supervised learning is the case where you have been given unlabeled data, but then algorithm automatically detects some kind of knowledge by way of interacting with the environment, and in the process it attaches labels to each other samples which are unlabeled. So this is now gaining ground, and many of the top researchers in the world like Jan LeCun, Yoshio Bengio, these are the people along with Hinton, they won the last year's Turing Award. So they have been advocating this now very vigorously. Representation learning, on the other hand, tries to figure out a kind of latent variables from the data. One simple example could be principal component analysis. If you extract principal components from an X matrix, okay, following the algorithm, then whatever principal components you get, they represent the knowledge or the information, or you can say variance available within the X matrix, but then in a where each of the principal component becomes orthogonal to one another. That beautiful property is not there in the original X matrix. So that is one simple example of representation learning, and there are many more examples one can give. For example, doc2vec, word2vec, and then BERT. Many are there. Glow is there. These are all the utilities using which we can actually represent the numbers. You can actually represent the text and the words within the text into number vectors, okay, numerical vectors, using some neural languages, neural modeling. Reinforcement learning has been there in statistics and operations research in the garb of Markov decision processes. But then for the last 10 years, it has been gaining a lot of ground thanks to its improvements. There are some bottlenecks, and those bottlenecks have been addressed by machine learning experts. And deep reinforcement learning, as well as its close cousin, deep reinforcement learning, DeepRL. So there is a marriage that has already taken place between deep learning and reinforcement learning, and the kid is called deep reinforcement learning. So that is gaining a lot of ground now, which has got properties of both deep learning as well as reinforcement learning. It has got immense applications, the driverless car and all those things. I can keep on giving examples. Deep learning, on the other hand, even though started in 1965 by Ivaknenko, it was not popularized at that time till 2006. That credit had to go to our great guy, Hinton. He brought in advanced concepts into the architecture of Ivaknenko, the GMDH, and then the rest is history. A lot of things have been done now. Every day we wake up, we keep hearing a lot of stories about new developments in deep learning. So this kind of excitement was there, I tell you, roughly about 20 years ago, when people estimated throughout the world in 24-hour horizon, when somebody wanted to measure or calibrate the popularity of the backpropagation algorithm for MLP, as all of us know, they estimated that at any given instance of time, 700 instances of MLP were running all over the world. So that was the kind of measure of popularity of backpropagation learning. And then again, that was due to this person along with other colleagues. But then the same guy, after he discovered backpropagation in 1986, exactly 20 years later, he came up with the concept of deep learning. And the rest of we can see a lot of architectures getting added to this bandwagon called deep learning, and there is no looking back. Many of the complicated problems and unthought of problems are being being solved by deep learning architectures. We'll have some slides over there. Statistical learning is very interesting. So statistical people, they said many of the things we started, and these computer scientists came and kind of they hijacked our kind of things, and they started developing their own counterparts and algorithms, which empirically appear to be superior, and then we can't do much about it. Then they said, rather than kind of competing with them, definitely some of the algorithms can compete very well from statistics family. They said, why don't we also give a kind of algorithmic flavor to statistical models? And that is how I have a separate slide on statistical learning. Several algorithms came into picture because of the efforts by the computer-oriented statisticians. So that field is called statistical computation or computational statistics. Okay, so in the process also a lot of learning takes place. And finally, transfer learning. So transfer learning is something like reading the book on your own versus listening to somebody on the same topic. If you're trying to read on your own, you will definitely learn something, and there will be a lot of holes kept in terms of concepts and clarification is required. On the other hand, if you hear somebody either online or offline medium, definitely those holes will be hopefully plugged. So you're taking the help of somebody in order to learn something. So his knowledge is transferring to you. That is called transfer learning. This simple example. So I understand that many of you are faculty. When you explain these difficult concepts, abstract concepts through examples, students will never forget. Okay. So this is some pedagogical tip from my side. So yeah, here we have mentioned several learnings, but then this particular slide talks about only 3, doesn't really matter. But why I picked this slide up is for the following reason. Some examples are also given here, and I don't have time to go through each one of them, but you can definitely go through. We'll be mentioning some of them in the subsequent slides. I have got a lot of things to cover. Okay. Now, if I want to look at timeline of AI, it was John McCarthy who coined this word called AI in 1956, and there is no looking back. 1960, first machine called perceptron was developed by McLeish and Pitts, and then 76, IBM 1997 Deep Blue, it beat Kasparov at chess, and several things happened. Okay. This is a much elaborate timeline of AI. Turing test was developed in 1950, right up to 2017. AlphaGo. AlphaGo was created by Google, a program based on deep learning architectures, deep reinforcement learning, and it started beating a world champion in a game called Go. Go is just like Chinese checkers, is a board game, but unlike chess, it has got much more complications. If you want to figure out 2 to the power of 170 combinations are there. These many possible positions. So human beings, yes, somehow mastered it, but imagine how a machine has mastered this. So it is much more complicated than chess, because a chess has got only 2 to the power of 125 possibilities. So it is so much more in alpha and Go game. Okay, so that is also mastered. And then if somebody says no, all these things are fine, how about pack of cards? So the pack of cards, one of the important popular games played in casinos is poker. So poker experts are there in the world, and it has defeated, AI algorithms have defeated 4 such champions, world champions in poker. And that is where again a lot of human number crunching is required in brain, but somehow it has mastered it again by using deep reinforcement learning, and many more are there. So these are the timelines for machine learning. I will not go through each one of them. Except that I would say that these guys, Schmidhuber, Hochreiter, these are the guys who gave rise to one architecture called long short-term memory network, that is LSTM, and Jan LeCun, etc. These are the people who worked on deep RBM. It's called a restricted Boltzmann machine, and CNN, etc. So several people came together and gave rise to a huge number of architectures, and each day we are coming out with different architectures in different applications. So these are some of the important milestones in deep learning. And then GAN, I'll mention about GAN in a while. GAN is very exciting architecture. Okay, Ian Goodfellow has developed this just as early as late as 2014. 6 years ago he developed. He's a PhD student, very young guy. But GAN has revolutionized the way that we think about solving the problems. And many problems can be solved using GAN. And new difficulties are created for humans. I'll talk about that in a while. So this is another example of telling you pictorially how supervised, unsupervised, and semi-supervised look like. Supervised learning, yes, it has got different label. These are circular guys. These are star shape, and these plus shape. But here everything is circle. But then you have to, that means the label defining their shape is not mentioned here in this data set on the unsupervised learning. But they are similar in some sense. So using clustering techniques, and a huge number of clustering algorithms are there, you can figure out the natural groupings in the data. Okay. And this is a mixture of both semi-supervised learning, as I mentioned already. So training from scratch is one example I told you. You can, there are a huge number of images is given to you, and then you have a convolution neural network, a deep learning architecture. Depending on the highest probability, the car has achieved 95% probability. So you put a tick mark, whether it's car or a truck or a bicycle, each one will have its probabilities, but the car is having highest probability, therefore it is car. That is how inference takes place. On the other hand, if you want to remove this middle portion, the convolution neural network, transfer learning says you give the data, but I have developed a CNN already in some other context. That particular pre-trained neural network I want to use, basically this is trained on cats and dogs. Here we are talking about cars. So it's taken from a different domain altogether, and you need to fine tune the network weights. Algorithm is not totally developed from scratch. And then a new task is given, car identification, and finally you get it. So this is what is known as transfer learning. And routinely we keep using transfer learning in our research work, in our Center of Excellence. Okay. And then representation learning, as I mentioned to you already, you try to identify and learn good features and representations. Simple example could be principal component analysis, already I mentioned. A close cousin of that is identical component, independent component analysis, and then restricted Boltzmann machine, RBM, and then CNN. Okay, so these are all the examples of representation learning. So they take the raw data, but then they figure out a very important features, which are functions of original features. Multiple composite functions happen over layers, and then you ultimately come out with very distilled information in the form of latent variables. And that is very, I would say, backbone of deep learning as far as one particular architecture is concerned. That is CNN. Okay, then we get into reinforcement learning. So simple diagram is there, agent is there here, environment is there. Agent always interacts with the environment, and while interacting, he does some action, and then after that, he observes environment. After interacting with the environment, he observes what is happening, and then if he does proper action, he gets reward, otherwise he gets punishment. Is at a very high level, cryptically spoken. If the same example is translated into self-driving car, car is the agent, environment is the road and traffic, and then if it is driving very smoothly, then we say, yes, car is given reward. What is the reward here? Basically, the error function will be minimized, okay, with manually. There are some, of course, when I say manually, it is not manually, arbitrarily it is minimized, it is programmed. So that car actually is given more speed and etc. On the other hand, if it hits a particular man or a vehicle or anything, then of course the algorithm will, actually car comes to a halt, and algorithm will be punished in the sense that the error will go to the very high stage, and then you will have to actually redevelop the algorithm. So that's a simple concept adopted here, but it has got fascinating applications. So reinforcement learning has got intersection with computer science, neuroscience, psychology, economics, mathematics, engineering. Not that it has got applications in all these areas. That is one important aspect. Importantly, it also draws from the concepts of each one of these areas. And this field, reinforcement learning, is growing like anything by learning some things from psychology, from mathematics, from economics, etc., etc. So this is a very exciting topic, but this is unlike any other machine learning paradigm. This different thing. I will not say difficult thing. It is a different thing. You will take some time. If you are working in neural networks for the last 10 years, I would say it will require some effort to understand what is the reinforcement learning, because there is no neural network per se. On the other hand, if you want to learn about deep reinforcement learning, in order to compute the Q function, what we call in reinforcement learning, value function, you need to train a neural network. So that is where the deep learning comes in over there. So it becomes deep reinforcement learning. This picture, yes, is there in the internet. I'm not a big fan of this picture, but it is, I'm putting this because you would be familiar with this and for the sake of completion. Otherwise, I am not a big fan, as I mentioned already. Deep learning is a subset of machine learning, and machine learning is a subset of artificial intelligence. Okay. Okay, the primary reason why I don't like this is, yes, there is a tremendous amount of overlap between AI and ML, and ML is not a proper subset of AI. That is my conjecture. And then, of course, deep learning is a part of machine learning, and many things what you do in AI are also part of ML. So this is a hazy thing. The lower circle deep learning belonging to machine learning, absolutely no argument about that. But I have issues about AI and ML because there is the boundary is very fuzzy. You cannot draw a very crisp boundary like this, circular boundary. Anyway, so now, if you want to understand what is deep learning, then look at the top portion of the slide. You have got raw input, which is given to the human, ingested into the machine, into the database, and you have to perform feature engineering. So feature engineering actually involves feature extraction and then feature selection. Feature extraction means features are not readily available. For example, you have been given image data. You have to basically convert that into a matrix. So matrix here, rows can be, let us say, columns. Rows can be rows of the matrix itself. And then the features, are we taking the pixels as features? Are we taking a collection of pixels? Is something not very clear. Are we taking grayscale image or color image? So anything is possible. But then how to extract knowledge in the form of features, in the form of variables, so that becomes moving away from unstructured format of the data to the structured format of the data. And this is where many things are possible. It need not be done in a unique way. Therefore, this process is called feature extraction. You have not been given features. Just imagine this is one case. If you all of us remember iris data, very simple data, one everybody is kind of familiar with. Iris data has got 150 rows, 150 flowers. It has got 4 columns. First column is sepal length, sepal width, petal width. Only 4 columns are there. Based on these millimeters, they are measured. Based on these measurements, first 50 are classified as iris setosa, second 50 iris virginica, third 50 iris versicolor. 3 different distinct flowers are there. It is having no missing values. It's a benchmark data set developed by Roland Fisher in 1936. People are still using it. Okay, it's such a good data set. It is a 3-class classification problem, very well behaved, no missing values. So here the features are the columns of the properties of the flower are defined to you already. So there is no need for going for feature extraction. In pictures, images, in text, you don't have that luxury. You have to create your own features. That process is called feature extraction. If you do feature extraction alone, you'll be, in the case of text-1 data, we have seen social media analytics data. In some cases, we have ended up with 5 lakh features, 500,000 features, mind you. So you cannot, if you ingest all those 5 lakh features into the algorithm, it is merely foolishness. So we have to reduce that number of features into a manageable number. So this reduction from a large number of features to a smaller manageable number, meaningful number of features is known as feature selection. So feature engineering involves feature extraction followed by feature selection. This has to be done by a human being, okay, in traditional machine learning. If you look at the top portion here, and then you'll get number of features, traditional ML algorithms are applied, and finally you get the output. Fine. Look at the bottom of the picture now. Here again, raw input is given. There is no feature engineering. You don't have to apply any algorithms. These are called, Hinton calls them as a handcrafted. So you don't have to apply any algorithm to extract important features, to select important features. No, you don't have to do that. Everything is done by the neural network itself. That is the reason so many layers are incorporated into deep learning architectures. So it does feature extraction, it does feature selection, it does everything for you. And finally, it gives output. Okay, and output, as I told you, this neural network can be used for classification, regression, etc. So these are fundamental difference between traditional machine learning and deep learning. If you want to look into the repertoire of algorithms available in deep learning paradigm, you got at a high level generative classes, generative category, discriminative category, and then unsupervised category. In generative, you have autoencoders. Autoencoders are there since 1989 in traditional machine learning. Professor Piri Baldi has given a 3-layered architecture, 5-layered architecture. It is input layer, then second layer is compression layer, then bottleneck layer, then decompression layer, and finally output layer. But the beauty is input variables are getting extracted, getting back at the output layer with small numerical errors. So these called auto association instead of hetero association. Y is a function of x1, x2, xn means hetero association, but x1, x2, xn is a function of x1, x2, xn means auto association. So that is what he achieved, and it has got a lot of applications. We did a lot of studies with autoencoders in the traditional machine learning sense by taking the help of evolutionary computation with our PhD students and MTech students, and a huge number of applications are there. But then in deep learning also, they try to accomplish the same autoencoder in a slightly different paradigm, different concepts are used. And then variational autoencoders, a variant of that, and generative adversarial neural networks. This is a fantastic thing that is actually making waves now. I'll have less time anyway. I have a lot of slides to cover. I'll come to that later on. Discriminative, RNN, recurrent neural networks, and then convolution neural networks. These two are primarily playing a lot of role right now in disease prediction, for time series forecasting, etc. Okay. Unsupervised, again, many are there. Restricted Boltzmann machine, deep belief network, deep Boltzmann machine. Okay. In order to learn each one of them, you require at least a 2-semester course, let me tell you. And you will be very thorough in that, both in theory as well as in practicals. So recently we have written a survey paper in knowledge-based systems. You can always go to my Google Scholar profile. Just type Vadlamani Ravi in Google Scholar, you will get it. So with 6 authors from 4 different countries, we have written this exciting research review article. You will like it, and the way that we have written, it is very useful for budding researchers. It could be faculty, it could be students who are registered for PhD. A lot of information is there. We have thrown open so many open problems using which you can actually work on the new problems. So these are all the platforms, and all of them are open source. That is the beauty. We are given the URLs and reference numbers. So many people are nowadays working in TensorFlow. Some people are working in PyTorch. Keras is very popular. Theano, till 2 years ago, people used to work. Some of my students worked, but now it has gone into back burner. Nobody is using. Big deal, some people are using now. And these are all things that we covered. Fraud detection in financial series, financial time series forecasting, prognosis and health monitoring, very important. Medical image processing, there is an exciting subsection, I must say. Here we included things like radiological image, whatever X-ray or MRI, CT scan you get, how to interpret them using deep learning architectures. Suppose some people have got a disease called glaucoma, a different eye disease, or retina. Because of high blood sugar, some people's retina will be spoiled. It's called diabetic retinopathy. How to detect them independent of doctors, independent of clinicians, just by looking at the image. So a lot of things are being done there. Power systems and recommendation systems, these are also exciting areas. So our survey is divided into 6 of them. If anyone of you is interested in any of these sub areas, definitely you should look at our paper. It's available. If you are interested, then you can just shoot off a mail to me. I'll supply that paper to you. Okay. It's already receiving 30 citations, 35 citations already within a span of 1 year. And these are data sets. See, where do we get data sets? We have given the sources for each of them. Okay, so new frontiers. These are the applications that I was asked to talk about, and I have some more later on. Then people said, okay, your computers and your neural networks, and you talk about whichever artifact that you have. People said they can only do number crunching. But there are some kind of activities which only human can do. For example, a painting, poem writing, essay writing, etc., or music. So these are all not involving number crunching. They are purely skill oriented and art oriented. Then these guys challenged the computer scientists or ML scientists, saying that, can you do something here? I'm sure you can fail. definitely you're going to fail. This kind of challenge, a kind of informal challenge took place, and then came the answers in the following way. Just look at this left hand side. She fell to the floor from her cries and muttered a soft, "Come to me." He stood rooted with fear. She slowly crawled spider-like towards him, etc., etc. If you read through, it is actually a horror story. But you cannot just figure out that it is written by a machine, which means algorithm, or a human being. It is actually written by a machine algorithm called Shelley, developed in MIT. Okay, so you can see the URL there, twitter.com Shelley.ai, given the media MIT. Okay, so here, so writing horror stories, okay, and just like the human being writes, how is it able to do? Because for training, it has been fed a lot of horror stories written by humans, and the output is a fresh story never written by any human being. That is the beauty. Similarly, for pictures, painting, a lot of Pablo Picasso's, very famous artist, his pictures, paintings were given as inputs, images to the network, and it has created its own kind of paintings, never done by anybody. Okay, and these examples keep on going. Similarly, music, it can create artificial music. You can see some of the mind-boggling achievements here in this slide. AI almost won literary prize in Japan just by writing short stories. Purely AI algorithm. Artificial paintings, real-time machine translation. How many of you use Skype? And how many of you using Skype know that machine translation happens in real time? You speak Telugu from this side, the other fellow can hear that in Malayalam or Tamil, if it is supported. Otherwise, maybe some languages are supported by Skype, some are not. So which means two people at the two ends of Skype can speak two distinct languages, and machine translation happens in real time. And they achieved it with great success. And DL, that is deep learning networks, diagnose glaucoma more accurately than human beings. Predictive maintenance is there. So predictive maintenance of aircraft and large equipment is very interesting aspect. Every equipment has to undergo maintenance in order to prevent failures. It's called preventive maintenance. Some of the spare parts will be replaced or repaired, but taking the help of big data analytics, and of course these machine learning algorithms, people can pinpointedly identify a particular set of spare parts whose life is over already due to wear and tear, and they can fail any moment. You cannot detect until it fails, but algorithm detects this well before you did. Therefore, it immediately suggests or recommends maintenance. So that's called predictive maintenance. Huge number of dollars are saved because of these applications. Recently, last month, Nobel Prize in chemistry or medicine was won for a field called gene editing. So gene therapy, if you can edit some of the genes at the genetic level, some diseases can be avoided. That is the whole idea. But that is a big data problem. So they have developed a CRISPR-Cas9 tool. Okay, these researchers, and just try to go through everything. Everything is big data analytics and machine learning only. Otherwise, they cannot do. So now that, let me tell you, there is no field left unimpacted by AI, ML, data science, machine learning. You can call it anything. Okay. Those slides are coming, interesting slides. And artificial music composition, development of new particles in physics, and periodic table creation in just 2 hours in chemistry, cognitive cooking by IBM Watson. Just Google cognitive cooking, very interesting things you'll get. I don't have time to explain now, unfortunately. And AI recreated the experiment that won the Nobel Prize in 2001. AlphaGo, as I told you, won Go versus Lee Sedol, who is the world champion in South Korean in 2016, is the complexity. AI liberators beat 4 professional poker players, intelligent healthcare, intelligent transportation, robotic surgeries. Robotic surgeries, even in Hyderabad, they are happening now. If you look at ads of Yashoda Hospital, they say this is much more clinical and precision oriented compared to human beings. Some of the parts are so intricate within our stomach or anywhere, our human hand cannot go, but robotic hand can go without emotion and do perfect surgery. Okay. Now we slightly shift the gears and talk about data. You will realize why we are talking about data here. Lots and lots of fields generate data. Example could be banking, telecom, other business transactions. Huge amount of data is created with the customers whenever customer interacts with them and does business. Scientific experiments and astronomy, biology, they also generate huge amount of data. If you talk about your own web and text and e-commerce, all of us are doing e-commerce day in and day out. A lot of data is generated, and whenever we do any transactions with respect to a bank or an insurance company or with respect to a university, user logs are created in a database. That is also data. And social media data, yes, huge amount of data is created. And then IoT. So these are the 6 different kinds of paradigms which are generating data with or without human intervention and with or without human knowledge. The data is becoming so much that per day we're generating 2.5 quintillions of data. Okay, 2.5 petabytes of data we are generating. And that is the reason to look at the right hand side. It is compared to a tsunami. Data flood, data deluge, data glut. You go whatever adjective you attach, that will be perfect. So now, very interesting slide. Science in its history has got 4 distinct paradigms. Entire scientific field. The first paradigm is called empirical science, where only experiments were conducted. It ran from, let us say, 1300, 1200 up to 1600. After 1600, people said, we are getting bored of conducting these experiments. Why don't we develop some theories which will support our experiments? Then a new strand of research started, which is called theoretical research. So laws of thermodynamics, etc. All these things are Newton's laws, etc. They came after 1600, and up to 1950, this field flourished like anything. And there is a symbiotic relationship between theoretical science as well as practical science. Because whenever some experiment is conducted, they would like to support it with theories. Whenever some theory is propounded, they wanted to support it with experiments. So that kind of synergistic relationship happened. This happened till 1950. The third paradigm of science started at that time. At that time, computers have just been coming into picture. They said, why don't we, and this particular thing did not happen in 1950, by the way, but during the 1970s, etc., they started doing all this. So before a drug comes to market, okay, it takes about 10 years from ideation to actually going to market. So 10 years, what do they do? You'll be surprised. First and foremost, you have to identify a molecule, a suitable molecule, which will bind with the molecules in the disease, right? Once the binding is perfect, then the disease gets cured. But who on earth will tell you which molecule has got this medicinal property? Okay, so this process is called molecular modeling. Google it, you will get it. Molecular modeling is an exciting field where this bond angle, bond strength, everything is computed. Quantum mechanical computations take place, but then everything is simulated on the machine before you actually go into lab scale testing, then large scale production and clinical testing, etc., etc. Okay, that is one example. Second example is, sorry, developing a new aircraft. Recently, we got second batch of Rafale aircrafts. So whenever you develop a military aircraft or even a civilian aircraft, it has to come with new features. So how do you test it? It's an expensive thing. Each one may be costing 1 billion. So you don't have to do that. You create a model of that on the machine and then start computing all these, start performing all the computations, simulate the environment, how it flies in the sky. The same thing you can simulate here on the machine. Okay. So these called computer simulation. These are the 2 examples and many more can be given. So this computational paradigm of science is unheard of. It is neither theory oriented nor experiment oriented, but it supports both of them. But come 2000, a totally 4th different paradigm of science has started, that is called data-driven science, data-driven paradigm. In this data-driven paradigm, people said, I don't need to conduct any experiments. I don't have any theories. Let me tell you, I cannot prove many of the things, whatever is there in neural networks, simulation, computation, etc. And then simulations, it is different from computations and computational paradigm, but it requires computations of a different kind, because my primary feeding material is data. I have to feed on data. I means the algorithm. So now the 4th paradigm of science started. So just to give you one information, CSIR India has got 37 research laboratories. One of them has got 2 of them are there in Bangalore. One of its name was CSR, Center for Mathematical Modeling and Computer Simulation. But 4 years ago, that name is changed to Fourth Paradigm Institute, Fourth PI. Just Google it, Fourth PI. Fourth PI means what? Fourth Paradigm Institute. Fourth paradigm is actually referring to this. Everything is data driven. Okay. So now here we talked about importance of data and the growth of data. Here we're talking about importance of data in science, and slowly we get getting into applications. If you buy a book on Amazon or maybe Flipkart, Advances in Knowledge Discovery in Data Mining, written by Han and Camber, world's bestseller. Apart from this book, Amazon also suggests some other books. The idea is Amazon is hoping that you will buy both the books. If you are a beginner and if you don't mind paying extra, you will buy both the books. Similarly, Google's predictive search. Before you type your search string, Google gives you some kind of recommendations. Gmail. The advertisements in Gmail are highly personalized because it depends on what you type. It could be personal, private, business, technical, academic, any bloody topic you type, entertainment. Google will actually see this with million eyes. And accordingly, those advertisements only will come to you, not to anybody else. So these are all the common applications we are experiencing in daily life of data mining. Having said this, just to give a perspective, UC Berkeley has estimated in 2003, 5 million terabytes was created in 2002. 2002 is a development watershed area, watershed year for the development of data. 5 exabytes, 5 million terabytes means 5 exabytes of data was created in one area alone. US consumed the most, but very little data will ever be looked at by human being. Therefore, we require data mining. But if you want to estimate now, every day we are generating 2.5 exabytes of data. Not forget about a year. The data challenge is on the x-axis you plot the timeline, years, y-axis database size. Database size is growing at exponential pace. Database utilization is growing at a linear pace. The question is, how do you bridge this yawning gap between the content generation, data utilization? Two solutions are there. First solution, you develop more and more sophisticated algorithms from machine learning, statistics, etc., etc. Deep learning, fine. Do we have depth of them? No. We have umpteen number of algorithms right now as we speak. The moment you get up now, if you are working in this field, my students, and myself, we actually jocularly say, sir, we are going to sleep now, tonight. Tomorrow when we wake up, we don't know how many algorithms will come if we Google. Such kind of pace is there because somebody else is working there in that night, the 24-hour horizon. Anyway, so sophisticated algorithms, yes, there is no depth. Many of them are there. But then comes the manpower. There is no manpower at all. Without manpower, the algorithms cannot run on their own. Therefore, you have seen for the last 6-7 years, top universities in the world, they started giving Master of Business Analytics, Master of Predictive Analytics, right? Master of AI, Master of Data Science. Now, IIT Hyderabad and one university in Nagpur, they started Bachelor of Engineering, BTech in AI, they started. I am not surprised. I know these trends are going to happen. And all business schools started a business analytics course, Master of Business Analytics, because we need, as we speak, I tell you, 1 lakh data miners are required in India. So many positions are vacant. So this was estimated by McKinsey in 2011. They talked about US, not about India. They said 200, that is 2 lakh data scientists were required in the US in 2011. Whether recruited or not, we do not know. But they projected by 2020 that number will become 1 million. So right now 1 million jobs are there in US, up for grabs. Data scientists they call. And who is data scientist, you will come to know in a while. So data miner, yes, it's a data mining means non-trivial process of extracting useful, non-obvious and actionable knowledge from huge masses of data. It's a consortium of statistics, OR, databases and machine learning and new AI. These 4 fields coming together, it becomes data mining. Please remember, if you exclude one field, it does not become data mining. That is number 1. Number 2, you should get knowledge. What kind of knowledge? You should get useful knowledge. You should not get any obvious knowledge which is known to you. No, you should get non-obvious knowledge. And then using that knowledge, you can take some decisions. If you are applying in business applications, you can take business decisions. If you are applying in science and engineering, you can take scientific decisions. These 3 things are must: useful, non-obvious and actionable knowledge. If any of these things are violated, then don't call it data mining. Simple example is this. Suppose we search for some string in Google. Do we get knowledge or information? We get information. That's called information retrieval. No, we're not getting any knowledge there. Suppose we search for how many students have got a distinction, A+ grade in our university, in our database. That is again information extraction, retrieval. It is not knowledge. But based on the current performance of the students, if we want to predict how many are going to get A+ next year, that is data mining. So whenever somebody says data mining, there is always a predictive angle involved there. And there are other things also. Okay, there are some tasks in data mining. I'll talk about that in the next few slides. So analytics is a related field. It describes, these are the three flavors: descriptive, predictive, and prescriptive. Descriptive means describing what is already known. You require fields like descriptive statistics and OLAP. Loans disbursed region-wise, year-wise, quarter-wise, customer-wise, etc. is a multi-dimensional query. You require OLAP for this. Simple SQL will not be sufficient. So here information you are providing what is already known. You come to the predictive flavor of analytics. You are predicting what is going to happen. Here you require fields like applied statistics, data mining, text mining, web mining. All the three you require. Predicting future NPAs. How many people are going to take loan and run away to London? Okay, you know what I mean. So that kind of thing. If not London, so change some other place. So these are called NPA, non-performing assets. So this is one example. I can give a number of examples. Providing insights. Cancer prediction is another example. Okay, when floods have come in Hyderabad just 2 weeks ago, when are we going to get the next round of floods of this nature, of this magnitude? Okay, we can predict possibly if we have proper data. And providing insights and recommendations. Sorry, somebody is saying something. Anyway, predicting ATM cash replenishment. Suppose you go to an ATM and there is no cash, you will be disappointed. Suppose there is excess cash, then bank will be disappointed because bank is not getting interest on the excess cash. It is lying idle. So excess cash should not be there. Low cash should not be there because both the parties will be disappointed, customer as well as bank. Now comes the question, what is the optimal amount of cash that should be replenished in the bank? Number one, how often it should be replenished. So this becomes a time series forecasting problem, which we solved. So having said that, these are the 5 tasks in data mining: association rule mining, classification, clustering, forecasting, outlet detection. Whichever data is the source, okay, whichever source is the data. For example, it could be structural data, it could be unstructured, it could be semi-structured. These 5 will not change, fortunately for us. That is the beauty of data mining. If these 5 remain, the 5 are remaining and data becomes unstructured data, then it becomes unstructured data mining. If it becomes text, it becomes text mining. If the data is coming from web and web related data, then it becomes web mining. That is how we have to understand. Okay, these are 2 basic. I will not go into the details of this because I have some more things to cover and time is catching up. If time permits, I'll come back again. So now data science is the newest word that we are hearing. So this has fields like applied stats, machine learning, new AI. New AI includes deep learning and deep RL. So you'll be wondering why this guy is using new AI, because I have been hearing this word since late 80s and early 90s. Everybody started developing expert systems. I was working as a scientist in CSR research laboratory in my first appointment. You talk to civil engineers, they say, yes, we are developing expert system. Structural engineers, yes. Earthquake engineers, yes, we are also developing. And then you come to suddenly fire engineers, they said, yes, we are also developing expert system. So everybody is on the bandwagon. Just now, everybody is in the bandwagon of deep learning. People are saying crazy about expert systems at that time. But then within a span of 2-3 years, everything died down. The reason is expert systems, whichever is there at that point in time, it did not have proper mathematical basis. Algorithms were not so sound. They could not stand the tests of complexity and survivability. Therefore, they lost. Nobody could see them. They are replaced by fuzzy-based expert systems, neural network-based expert systems. The word expert systems is sacrosanct. It is important. It needs to replicate the knowledge or inference mechanism of expert. But then underlying things, what the algorithm is going inside, that has changed. Okay, so at that time, AI means they used to have this breadth first technique, and depth first, and then hill climbing, and then we have got CBR, content based reasoning, then what instance based reasoning, and then KNN, very little amount of NLP. That's all. These were the monotonic reasoning, non-monotonic reasoning. These were the kind of things called AI. Anything that doesn't fall into that, they never said it is not AI. So much so, they never included neural networks and fuzzy logic into AI. I remember those fights. Then they said, no, you are machine learning, you are different. We are AI. Now, the thing is so much, it has become so, the AI people have become so generous now that statistics is also part of AI now. Now see the other extreme. At that time, they were all persecution. You are different, you are different, you are different. Now you combine all of them, I got the biggest umbrella under earth. So that is where you combine everything in that. Now I'm called AI. You are doing optimization, you are doing AI. You are doing game theory, yes, you are doing AI. You are doing statistics, yes, you are also AI. Now things have gone to that kind of madness. Anyway, so the new AI, I'm referring to deep learning and deep reinforcement learning. Operations research cannot be thrown away because every machine learning technique, every AI technique depends on optimization. Probabilistic models in terms of Markov decision processes, based in belief networks, etc., NLP, descriptive statistics, and OLAP. So this is a kind of expressing what is data science. Machine learning already I mentioned here. Now look at clustering. Now you will find several pictures like this in subsequent slides. If you look at clustering algorithms at a very high level, right now there are 50 clustering algorithms. Let me tell you, I did not encompass all of them. I took the samples only. K-means is the very popular. Its close cousin is K-medoids, DB-scan, fuzzy C-means, self-organizing map from neural nets, evolution computation, and evolving clustering method, evolution computation. These are the primary clustering algorithms coming from very distinct families. Okay. Forecasting, you see many of them. Multiple linear regression, lasso regression, principal component regression, ridge regression, partial least squares regression, quantile regression, Poisson regression, which is various neural networks, support vector regression, CART, neurofuzzy methods, evolution computation based regression. These many methods are there for performing regression problem, for solving regression problem or forecasting problem. And they are coming from different families, but they are helping each other, competing each other, and field is growing like anything. Classification, start with logistic regression, naive Bayes, various neural networks are there, support vector machine, decision trees, fuzzy rough classifiers, random forest, tree net, evolution computation, and many more can be added here. Association rule mining, fortunately it is not yet crowded. A priori algorithm, FP growth, and evolutionary. We have done extensive work here, evolution computation based association rule miners. You can look at our Google Scholar profile. Okay. So next we want to develop neural networks for performing association rule mining very soon. Outlet detection, probabilistic distribution based, probability distribution based, clustering based, auto associated neural network, which is auto encoder, one class SVM, evolution computation again, support vector machine, support vector data description, SVDD. So these are the 6 different methods for outlet detection, which is useful for fraud detection. So we have seen all tasks of data mining. Just see clustering, forecasting, classification, associational mining, outlier detection. Now comes statistical learning, which I promised. Within statistical learning, SVM was the first member. SVM is having the properties of statistics, optimization, as well as machine learning. That is the reason it's called machine. Latent digital allocation. I do not know how many of you knew this. It is actually useful for topic modeling. Given a corpus of data, how to pick up important topics. Topics are not keywords, but families of keywords. MCMC and Gibbs sampling, Markov chain Monte Carlo, Gaussian mixer models, hidden Markov models, conditional random field theory, RBM training, CART, mass, lasso regression, variational autoencoder. So these are all the examples of statistical learning, which have got predominantly statistical flavor, but they also behave like machine learning algorithms, which means there is a construct called training set, test set. You build each one of them on the training set, you predict on the test set, every story follows. Okay, whatever we do in machine learning. but the flavor is from statistics. So what I want to tell you, why am I putting all these slides? You may be wondering. So these are all, you can say, different techniques of machine learning, and these are the broad applications. And wherever these applications are there, clustering applications, you can think of applying all these things, and they have competing results. Okay, the performance is dataset dependent. That is the reason I put up these slides. Slowly, we are coming to the demystification. So this particular slide tells you, no matter you are working in machine learning or AI or data science or analytics or data mining, whichever you claim, this is this is like Bhagavad Gita for you. Okay, first and foremost, without data, you cannot work. That is the first thing. Without data, you cannot develop these models, fundamental thing. Second, the data, see, if it is, say, solving a business problem or a scientific problem, it is called problem understanding. So a data miner or a machine learning scientist cannot work in isolation. He has to work with a domain expert. And that particular expert spells out the problem and gives an amount of data. There is a constant dialogue between this guy, data scientist, and a business guy or a scientist guy, domain expert. And then after they understand each other, understand the data, then comes data preparation. This data preparation is so much important. It consumes 60 to 70% of the data, time and effort. Nowadays, this is being done little bit. Of course, we have to do, even though you are working in deep learning projects, you cannot do away with data preparation. There also you have to do. Then comes modeling. Modeling means you are developing a model, analytical model, ML model, machine learning model, whatever. So once you develop the model, you have to evaluate the performance. How do we evaluate? For each of the tasks, we have different evaluation metrics. For classification, we got classification accuracy, sensitivity, specificity, precision, recall, F1 measure, F2 measure, etc., etc. If you talk about clustering, you got other measures, silhouette measure, and all those things. And then if you go to association rule mining, you got things like lift, interestingness, and support, confidence, etc., etc. If you go to outlet detection, yes, there are other sparsity index is there. And for forecasting, you got RMSE value, NRMSE, SMAP, MAP, etc. So for each of the tasks of data mining, we have different metrics. Using those metrics, we can apply and figure out how well our algorithm is working on the given data on which it is trained. That is called evaluation from the mathematical perspective, right? But this arrow is going back to expert here. What is the meaning of this? This says that, hey guy, I tried to solve the problem specified by you, right? I also evaluated in my own way using mathematical means, but now you should tell me whether I satisfied your requirement or not. If that guy says, yes, you have satisfied my requirement, then evaluation to deployment, you have to come. In deployment stage, you have to basically use the developed model, whatever model is developed here and evaluated here, simply implement this in real time. Let it run autonomously. You understand my point? Let it run autonomously and data comes and it gives the results. Inside what happens, you know, don't call it black box. You know it. You take the output, it may not be the thing that you are expecting, then take with a pinch of salt, but you please accept it because you did so much of exercise. You took the help of mathematics, you took the help of domain expert in evaluating it, so don't doubt the results. Then come to monitoring phase. What is the kind of monitoring that you have to do? Continuously, you have to monitor the performance of the model. Why you have to monitor? The reason is the performance decays. The performance decays as indicated by the metric values. The reasons are many. Primary reasons are the data set changes. Why data set changes? Because nature changes. The equipment changes. If it is business, customer behavior changes. Because of all these changes, data set changes. Because data set changes, our training set undergoes transformation. If training set is changed, my model, which was built on 10 days ago, whatever training set was there is no longer relevant now. Therefore, I have to build the model all over again. That is the meaning of this outer circle. It's a continuous exercise. They call this as CRISP DM, cross industry standard process. CRISP means across any industry you do, any kind of project, you have to follow this template, or you can say framework. Then you can explain easily to others. You can communicate easily. You may be working in biology, he may be working in electrical engineering. But if you follow this crisp DM, you say, I did everything okay till data preparation stage. Yes, you will understand what is data preparation. That is the reason you have to follow this framework. So why I'm saying this is developed for data mining. The same thing you can apply for AI models also, ML models also, without any difficulty. So these are the modeling algorithms that I was talking about. This is a slide I promised, demystification. I need your attention, please. Look at the bottommost umbrella. I use the umbrella concept. There were fields like applied stats, operations research, machine learning, and databases. 4 fields were there. They were not talking to each other, no collaboration at all. They were working in their own way. But suddenly, a unifying concept called data mining came into picture. That picture, that data mining required help of all these 4. You get the point? So data mining algorithms, when you say you require logistic regression as well as neural network and decision tree, a support vector machine, etc., etc. So it's coming from all these families. So data mining is the first unifying force for all these 4 disciplines. Do you agree with me? So this happened before 2000. 90s to 2000, those 10 years, this small umbrella, lowest umbrella became like a glue. It acted like a glue for all these topics. Then after 2000, something interesting happened. Another umbrella got bigger. The umbrella is known as analytics. Analytics has got 3 different flavors. Where is the cursor? Yes. Analytics has got 3 different flavors. First is descriptive analytics, predictive analytics, prescriptive analytics. Within predictive analytics, data mining is there, which means our so-called big umbrella up to 2000 became a small part of the bigger umbrella called analytics here. Rest of things are also important. Okay. So this is the second important development in 2000s until 2015, like that. It continued, analytics continued for 15 years. Umbrella remained intact. Even now it is intact. But then it became much bigger now. After 2010, big data analytics, social media analytics, etc. came. After 2014, deep learning came. Therefore, you put all of them along with analytics, then the largest umbrella that you get, which is now known as data science. Is this clear, sir? You please explain this way to your students, to your fellow faculty, they will understand. All these fields are related. Use the umbrella concept and you'll be very successful. First of all, you will have mental map, clarity. You will not have any clutter in the mind. Second, student will not have any clutter. So gradually from bottom to up, we are growing, and this is how we are actually explaining. Okay, fine. So if we talk about applications in biotechnology, as I mentioned already, a lot of applications are there. Gaming and hospitality industry, government, Indian government is using, undivided AP was using. I do not know about now, whether 2 entities are using or not, but undivided AP was using to detect the Maoist movements by tracing their conversations tower to tower, not cell to cell. It was done early 2000s. Later on, I don't know. But the same model, same philosophy is now copied by Delhi police. They were also doing that. Energy system, many things are happening in energy, smart meters and all those things. Finance, lot of things. You don't have to hire a broker now if you have an algorithm at your hand. And there are platforms which are run by algorithms. Of course, you have to pay some fees. For investing, they will tell you which stock to invest, which stock to actually sell off, and which stock to hold. Basically 3 decisions: buying, selling, holding. All these 3 decisions you either depend on human broker or a intelligent broker like algorithm. It's called high frequency trading or algorithmic trading. Healthcare, I told you, a lot of applications are there just to help the physicians. See, I tell you, if you remember 20 years ago, 25 years ago, these X-rays, CT scan, MRI, all these things were not there. But then over a period of time, I will not say doctors have become less confident, but they wanted to have more data. They want to take informed decisions. They have got some experience. That is one part of the data. They want to take the help of imageries, radiological imageries, and interpretation of the radiologist. That is second. It's called data fusion. Data fusion is coming, and that is where now they said, okay, we have this, we have that also. Let us take the help of the machine learning technologies. Let them also interpret. So it is again data fusion is happening in that sense. and the results are fantastic. Okay, insurance sector. So insurance sector is very dangerous, unlike banking, as far as fraud detection is concerned. It is difficult for insurance companies to detect fraudulent claims. It takes about 6 months to detect a fraudulent claim, whereas in banking, within minutes they can figure out whether they're figuring or not fixing the responsibility. I am not questioning that, but they have the capability. In insurance, it is not there because a lot of unstructured data is there. Manufacturing industry 4.0, they say. Industry 4.0 is full of analytics 4.0. Retail, internet, pharmaceuticals, I told you already. Telecom is just like banking. You identify what is the call pattern and accordingly give freebies to those kind of customers. Now with Geo, everything is free. Okay, that's a different kind of marketing model. So this list is endless now. I particularly would like to speak about agriculture. So we have been saying that Israel has got precision technology, precision agriculture, etc. Yes, agreed. Precision agriculture to what extent? You have to question. You go to Google Maps, just zoom in the Central Asia or East Asia. There, Middle East. There you see, just concentrate on Israel and adjoining areas. Everything surrounding areas are all deserts, but Israel is green. How is it possible? A country being green, relatively green compared to all surrounding areas which are deserts, because they applied agriculture, precision agriculture, with very small amount of water injected by nozzles. Okay, injected by nozzles, interpreted with the help of an algorithm, and everything is connected to IoT. It's managed in a cloud, and algorithms are dictating how much water should be given to the root. It should not be wasted, and in what quantities and how much frequency. So that is how they are doing. NLP, lot of applications are there already. Image processing, virtual personal assistants. We have some slide on that. Self-driving cars, fraud detection, yes, handwritten recognition, healthcare. So recently in a project we have noticed, if it is online handwritten recognition, we can get more than 95%. If it is offline, we are getting problems. Okay. So intelligent character recognition, OCR versus ICR, that is coming now. Manufacturing, gaming, credit card fraud detection, financial market analysis. All. Don't think that I'm just reading, but then yes, if I have to explain each one of them, I require another 3 hours. But we want to give a glimpse of all these applications. Sentiment analysis is very important. So we should like to know, it's called word of mouth marketing, retail marketing, also same example. So that guy maybe would have scored about 60 marks in English in his 10th class as well as intermediate, because his language is so poor. But after 3 years, 5 years, he got into a kind of job, and then kind of well paid also. He uses his internet credit card so often, and suddenly something happens, some bad experience happens with the internet and the credit card. He blasts the bank going to the social media. Now, whatever things that he could not accomplish in 10th class and intermediate, he writes big stories of his bad experience, for which if somebody evaluates, a teacher should give 100 marks out of 10. It's not 10 out of 100, 100 marks out of 10 he should be given. Such a beautiful English he writes. He should have written that kind of English in 10th and intermediate. So that means what I want to say is that all of a sudden, a lot of linguistic skills come when we want to express our displeasure, bad experience. And bad experience, we tell only two people. One who does ask you, one who does not ask you. We tell everybody. That means that is where social media is coming in very handy. Just blurt out anything, type few lines or essays on the social media, rest of things are taken care of by social media. Everybody will read. It's called word of mouth, electronic word of mouth. So using this, people, the bankers can actually determine what is the problem, set of problems they're facing, which products are doing well, which products they should retire, new products they should get, how our services are happening, how our staff are behaving with the customers. All these things they can know by performing sentiment analysis, which is unstructured data again, applying structured data on top of the structured form, whatever you get. In order to get structured form again, you can go to doc2vec, word2vec, document term matrix, etc. Many things are there. Computer networks, yes. Network intrusion detection is becoming more and more sophisticated. The other day I was reading some applications of 5G. 5G is full of analytics and AI applications. Okay. And then computer networks like the software defined network. SOC, Security Operating Center, huge amount of data is generated. So before an intruder comes into your network, he gives you warnings. He does a recce, just like a normal terrorist. Recce means reconnaissance. He visits not like a normal user like you and me. He does not perform any financial transaction, but he just comes and visits. He just takes note of all the vulnerabilities in the servers. Okay, and keeps in very tight notes, and then goes back quietly and goes. The next time that when he visits, he tries to attack those kind of vulnerable points, vulnerable servers, and then within few minutes, entire your DNS server and many of the things servers are in his control. Therefore, he can perform not just phishing, farming attack. Farming attack means what? All the customers of your bank, he can draw the funds, cipher of the funds. Those things are possible now. So I wanted to talk about GAN. Now time, yeah, okay, now we have time. How many more slides are there? Okay, let me just finish the slides. GAN is very exciting. We are working on GAN, so I wanted to speak about that. Did we miss anything? Speech recognition is very important. Search engines, recommendation engines, etc. Yes. So agriculture already I mentioned. IoT is being applied. So you can actually predict crop yield, irrigation management. So these are all recommendations you can make by proper decision making with the help of algorithms. Weather prediction, disease detection. Recently, this thing came in a newspaper. A lot of onions, about 25% onions are rotten in the warehouse. A girl has come out with a very intelligent solution. She keeps sensors at very vantage points in the warehouse for every maybe 10 kilos of bucket. These things buckets or so boxes. These sensors detect the smell, and whenever onion gets spoiled, some gases are emanated, it seems. So this has got chemical sensors. It immediately connects to the network, internet, and gives her a kind of signal. Immediately, she will prompt the kind of warehouse keepers, and they say they have to clear that. They have to sell it somehow at a low cost, doesn't matter. Otherwise, everything will go waste. So such kind of things have been done by a Nagpur-based girl. She is just a graduate in engineering. So that kind of things are possible now. So weed detection, nutrient management, crop harvesting, demand management, production planning, etc., etc. And the supply chain, this is what I was talking about. You can have supervised learning, unsupervised learning, reinforcement learning. What kind of data? You can get soil data, weather data, yield data, GS. See, all these data are fortunately available to you. When I started my career 32 years ago, we had depth of data. Now we have plenty of data. What we don't have right now, we means the students, they don't have is time. They don't have time. They're always hooked up to this stupid gadget and social media. That's all. They're wasting time. Otherwise, with the click of a mouse, they can learn many things. PhDs can become faster compared to our days because everything is available now. Fine. So you can perform all these things, and then performance like economic yield, social, environmental, all these things you can achieve. This is a fantastic diagram. I liked it very much. Okay. Then 5G applications. Network function virtualizations, cloud radio access network. So these are all intricate concepts of 5G. But then in each of the stages, we got machine learning applications. That's what we mentioned here. Okay, I will not go through the details, but you can just Google this. You can get it. Energy efficient 5G networks using machine learning. So basically energy minimization. Until the 4th generation, the focus was to deliver high data rate. The technology such as the IoT has resulted in billions of connected devices and the generation of enormous volumes of data. It is expected that traffic volume will increase exponentially and it will become 1,000-folds by 2020. The number of connected devices will continue to increase exponentially. Therefore, when you go for 5G, the latency is going to be minimal, almost nil compared to what we have now. And data rates will be much faster. We cannot even imagine. But then that requires edge intelligence. We have some slides there, edge computing and all. So these are banking applications. Okay, so this we are referring to this particular booklet. I have a booklet here. We recently launched with the help of Microsoft and bankers. So all of you please take a look. AI in banking. It is freely downloadable from IDRBT website. Many interesting things are given here. You can actually go through them to figure out the applications of banking, AI in banking. So these slides are taken from that customer experience, AI-powered employees, AI-powered insights. Healthcare, I told you, you can have personalized medicine or treatment, smart health records. Health records, I tell you, very interesting. I don't know how many of you visited LV Prasad Eye Institute, not for disease treatment, just for curiosity. So there I figured out they have developed electronic health records for the first time in India, very robust one. And based on their success, they have been invited to develop such kind of things in Africa. So once you have perfect health records are nothing but a database of various patients, just like customers or even students in a university. Okay. Sorry. Diseases identification and diagnosis, drug discovery and manufacturing, medical imaging, disease prediction. These are all the different applications in healthcare domain. And yeah, this may be small, difficult to read. I leave it to you. Brain tumors, again, we take the help of deep learning. I told you the source is given again, the Science Direct, that is Elsevier publication. In manufacturing, again, so people are talking about digital twins now, industry 4.0. So there, again, you have got a lot of applications of ML, right from the design stage to process planning, to building, to post-processing and test and validation, and finally going to the production stage. In all these stages, you can apply machine learning algorithms. Earlier, it was possible to some extent, but computing was not there. If it was there, it was very expensive. Memory was expensive. Because all those things have come down, data availability has grown up like anything. All these applications are possible. Please remember, that is a very important point. That is the reason we are able to see all these applications. So this is another diagram which tells you the flavors of different learning and the corresponding instances, different algorithms under that. Speech recognition, spoken language processing, and speech signal processing. So if you want to do this for, let us say, natural language processing, people say NLU and NLG, two are required. If you are developing a chatbot, a virtual assistant, you should be able to understand your language first, what you are speaking. That's called NLU, natural language understanding. Second thing is, it should generate a reply to you which is suitable, which is appropriate, not kind of any kind of stupid answer it should not give you. Therefore, that is called natural language generation. So NLP has got two parts, NLU and NLG. For both of them, nowadays, deep learning is applied. We developed a chatbot here in IDRBT, and we are going to sell it. So we started experiencing this with Apple Siri in 2011, roughly 9 years ago. Then Google Now, Microsoft Cortana, Alexa of Amazon, and then finally Google Assistant again 2016. These are the most popular ones which are available in your gadgets or even laptops, but then many more are there. And then edge intelligence and intelligent edge. So now things are taking a different shape altogether. All of us know cloud computing. One layer below is called fog computing. One further layer below is called edge computing, which means all the devices, gadgets, etc., they are called edges. So if you want to implement IoT appropriately, car has got sensors. Car is one of the edges. Mobile has got sensors. It becomes one of the edges. Your refrigerator is one of the edges. So like this, wherever kind of data streaming goes in and out, that becomes edge whenever it's connected to other things in the internet, in the IoT system. So these are edges, and then you have to make it intelligent. So therefore, you can deploy some of these machine learning algorithms on the edge itself. So how many of you know that our mobile phones have got a lot of deep learning architectures already involved? You may not know. For example, Apple Siri, this is not Apple, this is Samsung, but Apple Siri has got LSTM network already implemented there. So that is edge intelligence. That kind of things we are talking about. Okay, so connected cars and all those things, you can virtually connect anything to anything. So virtualizing edge computing infrastructure and networks. So here we are giving an architecture of hardware, and thanks to accelerators now. I'm sure you heard of accelerators. I suggest you to take a look at this particular thing. IEEE Micro is a magazine. They talk about a special issue they released, machine learning acceleration. Machine learning acceleration. What does that mean? What that means is the so-called new deep learning architectures require special kind of hardware. The von Neumann architecture has got bottlenecks. So they are developing accelerators. The name itself indicates it speeds up the process with the help of GPUs and other things. Memristors have come. Memory plus resistor, memristors. So that has come now. So these are other advancements in the hardware which are propelling this field called deep learning. And it has got again a lot of applications. That is the reason he's showing hardware here, edge hardware. So challenges are many. Applications are over now. We are coming to the fag end of the lecture. Challenges like class imbalance. Class imbalance, unfortunately, is there. It occurs naturally when we cannot do much about it. But then we have workarounds like balancing the data, oversampling, undersampling, smoting. That is where GAN is applied. Okay, GAN is having two neural networks, competing neural networks. One neural network generates the data. Another neural network validates the generation of the data. It receives, first neural network receives random data and generates patterns. The second network, which is called generator, this is called this generator, the second one is called discriminator. That discriminates between original input and the generated input. If the difference is low, then it will be taken as the true input. So, but this looks simple. This is not a lot of applications. You'll be scared if I tell one application called deep fakes. Deep fakes. So you can create an application where you'll be delivering a speech, or you'll be talking to your friends in a hotel or somewhere you're chit-chatting. Your face will be taken, entire video will be taken, not just face, entire video will be taken. Using GAN, they can recreate the conversation so that all bad things will still keep on coming from your mouth, which you never uttered in your life. It can happen to politicians. So that is the side effect, undesired side effect of deep learning. But nowadays, there are again models developed which will arrest this kind of deepfake phenomenon. Open and public benchmarks are developed. They are still not there. Concept drift. Suddenly, there's a drift or change in the concept. The phenomenon changes. Then the training data undergoes tremendous change. You'll have to fit the model all over again. Adversarial learning. This is a beautiful example. Suppose you are having a self-driving car, right? Everybody looks at that symbol, stop. If it is not attacked by any guy, okay? So basically what happens, that stop symbol is taken as an image, and image is processed within the machine, within the car, and then immediately take a stop or take a right turn or left turn. 3 actions are there, but you should not go straight. Okay, that is the decision. But now that image gets corrupted by a noise. Somebody has attacked that. Therefore, to the outsider, to the human eye, it looks like a stop, but for the computer, for the algorithm, it doesn't look like a stop. It is just masked. Because stop, it did not see stop at all. It keeps on going and the accident takes place. That is called adversarial attack on the machine learning. So these attackers are not keeping quiet. They are attacking your data. They are attacking your servers. They are attacking algorithms also. So now adversarial learning means before suppose that happens, then how do we safeguard our machine learning algorithm so that it can, even though that attack takes place, it still takes the right decision. So right now that is the hottest area of research in the US and elsewhere. You understand what I mean? Interpretability of models. So fortunately, we have only one model or a couple of models which are interpretable. Fuzzy logic based models, all rule based models, and evolutionary computation based models, if they generate rules, these are all interpretable models. They are called transparent boxes. Everything else is black box. So nowadays there is an exciting area in machine learning called explainable AI, interpretable AI. For that, the genesis, the starting point is this only. The decision tree is the starting point. But how to make every other machine learning algorithm as explainable, if not as a decision tree. So that is an exciting area of research. Deep learning for edge computing. So deep learning requires a huge amount of time for training, but once it is trained, you can place it on an edge. Just the executable, you can locate on an edge. That doesn't require much of a memory and power. That is the meaning of this. Ambiguous performance metrics, generalization of EOI, hybrid model modification, coordination between training and inference, and edge for data processing, microservice for HDL services, incentive and trust offloading mechanism, etc. Data parallelism versus model parallelism. So data parallelism talks about taking into, I'm just having just 3 more minutes, I'll finish it off. Data parallelism means whenever we ingest the data in a Spark or maybe Hadoop, the data gets automatically parallelized because of HDFS, Hadoop Distributed File System. That is called data parallelism. But then who parallelizes the model or algorithm? That is what we have to do. As a researcher, we have to do this. When both happen, then only we claim that our model is completely parallelized and implemented in a distributed environment, which is what is required for big data analytics. Okay, so that is something that people are still figuring out. A lot of success has been done, but has been done. We produced one PhD thesis in this area. Now, where is the training data coming from? Asynchronous fuzzy logic at edge, and then asynchronous FL means federated learning. Transfer learning based training. So federated learning means algorithm gets trained, but at different locations in a distributed manner, just like big data, a Spark system or a Hadoop system. So this is called intelligent edge. Performance, fault tolerance, privacy, and portability. These are the challenges. Unsupervised machine learning for network research challenges. Okay, energy efficiency in 5G. So many open issues are there. These are all research problems, let me tell you. If you closely read through them and look at the papers that we cited here, definitely at least 5 to 10 PhDs can be done here. So this is where I stop, unless there are any questions. Rajgaru, over to you. Any questions, please?
Yeah, my dear participants, please interact with sir with your questions.
We have 38 participants. At least 38 questions should be there.
Yes, sir. Yes, sir.
If not 38, 3 questions.
Yes, sir.
3 plus 8.
Yes, sir. Yes, sir.
3 minutes 8. Don't make 3 minutes 8. That means I ask questions to you. You should ask me questions.
Yes, sir. Yes, sir. Yeah, my dear participants, please, you can ask the questions. It's really a very great opportunity to interact with our sir.
I'm just trying to see any participant is known to me or not.
Yes, sir.
By any chance.
Yes, sir.
No, none of them appear to be known to me. No issues. For question answering, we don't have to know each other. Just curious. I'm a curious guy. That's all. Anyway. Yes, please ask questions. I know in a short period of 1.5 hours, we threw a lot of things, but I want to ask this simple thing. Could I demystify the concepts or not? If answer is yes, then I did my duty. Second question, did we give you gamut, entire bird's eye view of applications or not? If answer is yes, I'm successful. In the research challenges, if we could give you at least 2-3 ideas, then I believe I am successful. Now I asked only 3 questions. See, now answering should be easy. I thought questioning is easy, but you chose the wrong path. Now you have to answer.
Participants,
which is easier.
Yes, sir. Yes, sir. Participants, please, one of you can interact here.
See, I know how much of pains Dr. Janardhan, and I can vouch for myself how much of pains I have taken in preparing these slides. You should take pain for 1 or 2 minutes to ask questions. Don't feel shy. Everybody is a learner. I have to learn many things. I purchase books. I'm 55 years old. I have to learn. Otherwise, I become stale. It's a lifelong learning. Don't feel shy. There are many things that I do not know. Sir, did you tell them that if they ask questions, you will charge them more?
Sir, no, sir. No, sir.
I'm joking. So you have to incentivize them.
Yeah.
Whoever asks questions, that registration fees is given back.
Yeah, sure,
Then
sir.
I will hear hazard questions.
Yes, sir. Surely I'll try to implement from next time onwards, sir.
Yes, sir. Some small thing, a perk will be given. Okay.
Yes.
Like, sir, there is small question, sir, from my side. Myself, Dr. Rameshwaraya, one of the coordinator for this program.
Yes, sir. Please go ahead.
What is the actual difference between supervised and self-supervised learnings?
Yes. In supervised learning, we have an algorithm which we are controlling. In self-supervised learning, it is a newest area come about 1 or 2 years ago.
Okay.
So things are being developed. There also, we have algorithms where we have some control. There are some hyperparameters we can control.
Okay.
But there is something called adaptation. It learns things adaptively. See, I give you a simple example. If you learn genetic algorithms, let us say.
Okay.
In genetic algorithms, we have to fix the parameters of crossover rate, mutation rate, and number of generations, number of population size. These are the 4 hyperparameters.
Okay.
Now, I give some values in the first initial iteration.
Okay.
And let the GA run.
Okay.
If it is self-adaptive, it should identify on its own what is the appropriate value of crossover rate, mutation rate, number of generations, and population size by itself without my intervention and start doing it. So I believe adaptability or adaptive learning is part of the self-supervised learning with respect to hyperparameter tuning. There is nothing much otherwise.
Okay. Okay. That is also called supervised learning.
It is supervised learning, but the self is coming in this way.
With limitations.
Limitation? What kind of limitation?
Like you are fixing some parameters.
No, initially to initiate the algorithm, we have to fix, but they will undergo change in the subsequent iterations.
Okay, normal itself. No, but supervised algorithm also, sir. By experience, it will fix itself, now, sir. By undergoing process.
No, it doesn't happen. It doesn't happen.
By experience.
Okay, I tell you. I think you are getting confused with dynamic. Okay. Dynamic tuning is different from adaptive tuning. Dynamic means I fix the crossover rate, let us say at 2.0, and put a geometric progression. So dynamically, every subsequent iteration, 2 into 1 minus 99, 0.99%. With that time steps, it will keep on reducing. That is dynamic reduction or dynamic learning. Still, it's called dynamic, but it's not adaptive. Adaptive means by looking at the performance of the algorithm, it determines automatically what should be the value of crossover rate, mutation rate, etc.
Okay.
I have not worked on the self-supervised learning yet.
Okay.
From whatever I read, this is the thing I got.
Thank you, sir. Thank you very much.
Yes, thank you.
Thank you.
Yeah.
Good afternoon, sir.
Your good name, please.
My name is Bikram Vikas Das. I have completed my MTech in Pondicherry University. Currently, I have joined PhD. So my research.
Where did you join?
I have joined PhD in Tezpur University. I am from Assam. I want to know how my research area is network function virtualization, sir.
Okay.
So in that area, sir, how the machine learning and deep learning algorithms can be applicable in that area, like network function virtualization.
Network function? Can you repeat?
Virtualization, sir.
Virtualization, yeah. So
yes, sir.
Anyway, so when I mentioned all these things, don't be under the assumption or illusion that I worked in all those areas. So, but this is the one that I'm going to get into. So there is a body of literature, especially I can give you some suggestions. You can go to sciencedirect.com.
Okay, sir.
Okay, Springer 1, Springer Link, IEEE Explore, and ACM Digital Library. These are the 4 digital libraries you can search. Definitely you can find a lot of applications because this is catching up now. Okay, this is a virgin area. A lot of things are not yet been done. Okay. But I myself have not worked in that. I'm sorry.
Okay, sir. Thank you, sir.
Yes. Welcome. Well, if no more questions, then thank you everybody for your patient listening. Dr. Rajgaru, any question from your side?
Sir, actually, the one somebody is from. Can I tell my research area is machine learning or deep learning? I think something is different. That's what I feel even.
Depending on, so you have to speak something, then you ask me that question. Tell me 1 or 2 sentences what you are doing, then I'll tell you where you are working.
No, sir. Yeah. I think it seems what I can understand with this question from the participant is that whether machine learning or deep learning can be considered as a one sort of area. I think so. Research area like that. What I understood, sir, from one of our participants.
I tell you. Very interesting question. For some of the applications like sentiment analysis, recently for structured data, that is credit card fraud detection, and then one more application, 3 different occasions, we applied both machine learning algorithms as well as deep learning algorithms. To our surprise, we found that machine learning algorithms actually beaten deep learning algorithms. Then we thought, is it a negative result on deep learning? When entire world is chanting like Ram Nam, deep learning like that, why are we getting this negative result? So we went boldly. I presented this paper in a conference in US, in Berkeley. There, the chair and several other participants asked me, what are you presenting here? I said, whatever results I got, honestly, we are presenting. Then they asked me questions, reasons why deep learning algorithms did not perform so well as machine learning algorithm like support vector machine. Answer is very simple. Please remember this. This is a good question. Answer is very simple. If the features or the variables are informative and discriminative, which means they contain a lot of information themselves, and they're able to discriminate the samples into multiple classes correctly, sufficiently well, you don't require deep learning at all. Your machine learning algorithms are good enough. Don't go for sophistication just for the sake of sophistication, or your paper gets accepted. Your paper gets accepted even if you apply deep learning algorithms and still they don't perform so well. You can say, yes, that is the result I got. But be honest with your results and reporting. You get the point. On the other hand, there are instances, these were structured data I said, and even unstructured data also we got. There are instances where deep learning algorithms, the problem is that they require huge amount of data. Whereas machine learning algorithms, they don't require that much. That is the important thing. So in many occasions, we don't have those many millions of records or samples we require for a deep learning algorithms to perform really well. In real life, we don't have those many. And whenever we have, they perform really well. Their machine learning algorithms cannot perform so well. So that's the kind of line you have to draw. I do not know whether I gave more information or I confused you. There is a chat here, but anyway.
Yes, the chat is here, sir, but the questions are not posted. Only one question which I asked for just now, that was from chat only, sir, from one of our participants.
Okay.
Yeah, I think it seems no other questions from the participants, sir.
Somebody asked, what is the purpose of GAN? I told you, GAN is Sanghirsh Bhavana. Okay. Madam, the purpose of GAN is very interesting. GAN is useful for data imputation. When you have data balance problem, for the minority class, you want to create samples which are mimicking the reality. Okay, but you cannot generate them in the reality because the system does not permit. For example, fraud is an example, fraud detection. In your bank or any organization, the number of frauds is disproportionately very small compared to huge number of genuine transactions. You cannot artificially increase the number of frauds here. You can do data balancing, many more things, but you cannot create samples which mimic like fraud. SMOT is one example in the direction, but it failed for some reasons. Therefore, what GAN did is, GAN observed the distribution, probability distribution properties of these minority class, which is fraud samples, and created samples from similar probability distribution, which you and I do not know, but GAN figured out. We did this experiment. You can find this paper in our Google Scholar profile. ICISS recent paper, you can see. If you want, I can supply that. Therefore, what I'm saying is, we did that, and then results are spectacular. compared to oversampling, undersampling, and smoting. We compared with them. We have to compare with the baseline at the time. Okay, thank you so much. Very interesting questions. All the best. So happy data mining, happy data science to all of you. Keep the interest sustainable, and every day whenever you wake up, you pray God, immediately look at your web, whether you're getting new algorithms or not. Thank you so much. Thank you, everybody. I'm leaving the meeting.
Sir, 1 second, sir. Sir, please, sir.
Yeah, thank you.
Sir, let me give just a few points on your overall session.
Yeah, please.
Thank you, sir. Thank you very much for your exhaustive and very informative and very useful session, sir. Just is once again, it's my privilege to highlight few points which what I understood from this lecture.
Yeah.
The way you started the lecture with statement that why should we learn AI ML? Then you have started giving the timelines for artificial intelligence. Then since 1956 to till date. Again, you have given the timelines for again machine learning. Again, since 1952 till date. Then deep learning timelines. It was really very impressive, sir. In fact, it was very motivative after seeing the complete timelines on 3 important areas. We have started with lecture with the types of learning, where you have discuss in general what majority of our participants. In fact, I am sorry if my side if is wrong. Usually, self supervised learning, unsupervised learning, or even maybe self-supervised learning or even reinforced learning. Apart from this, other different learnings which you have introduced here, and in fact in detail you could able to explain. No doubt that the people might have got complete concept on this. Then you started with deep learning, sir. Again, you explained in detail the generative, discriminative, and even unsupervised in this. Then in depth, sir, you have discussed about distribution of surveyed articles by application areas wise. You have shown a very different number of articles application wise, really, which definitely will be very much useful for all the participants who are so attentive for their future research to get very good motivation. Started with data science, then new frontiers, like that many areas you have shown. Then AI almost won a literary prize in Japan. Once again, it will very much which will give very good motivation to all the participants. Then artificial, even paintings, then artificial music composition. In fact, something different, new. Then even can be applied even for for new particles in physics. Then trends leading to data, food or flood. Then different paradigms you have explained. First paradigm, second paradigm, third paradigm since again 1600 years. Then data challenge you explained the significance of data with the data content and data utilization. Data scientist, the way you have explained the significance or even application of data science in different areas, and even the demand in coming future for data scientists. It was really very impressive, sir. Then at the same time, types of analytics. In fact, descriptive, predictive, and normative also can be called as prescriptive. In a depth, you have explained in a very right fashion. We could able to understand. Then what are the various tasks in data mining, which are association rules, or classification, clustering, forecasting, or regression, or outlier descriptions. Then data science techniques, descriptive wise breakup, and you have shown a very good matrix which has 4 quadrants. In the center, we have the diagram in the machine learning, where the first quadrant left topmost is normal a CBRRL, then right side second quadrant SVR, then naive, Bayes, and decision trees. In fact, this no doubt the diagram will give somewhat easy way to understand what are the various algorithms which the machine learning has. At the same time, popular clustering algorithms you have explained, sir, and
I have one meeting to attend.
Yes, over, sir. It's 10 seconds, sir. Then different types of regression algorithms, apart from simple and multiple regressions, then association analysis. With all these things, Hope every participant who are attentive in the session might be benefited a lot, sir. Once again, thanks from my side on behalf of my personal behalf, on behalf of our institution, on behalf of our coordinator, Dr. K. Rameshwari Garu, for our excellent and wonderful session. It was very informative, sir. Thank you very much for sharing your valuable time and kind consent. Thank you, sir. Thank you very much.
Thank you, Dr. Janardhan Garu, for inviting me.
Yes, sir.
I'm happy to share my thoughts and experiences with all the participants.
Yes,
I hope it was a useful session to all of you. Thank you so much.
Thank you, sir.
Thank you.